process of translating a text from a source language to a target language preserves some properties. The main property to preserve, but not the only one, is meaning. How to, how to acquire the required knowledge, resources such as mapping rules and bilingual dictionary. Now, machine translation is nothing but you have Google Translation, or we can have Google Assistant or Alexa or Siri. All these are few examples of machine translation. But in Google Translation, you are keying in the input. In Google Assistant, your input will be voice. In Alexa and Siri, your input will be in the form of voice. So, but whatever be the type of input, ultimately you are translating. It will be converted to text. It will be converted to text. You will be translating a text from a source language to a target language. Preserving some properties is nothing but you are preserving the same meaning of that input text. So machine translation system, you have human translation with machine support, machine translation with human support, fully automated translation. Now, in fully automated translation, you can see we are using statistical machine translation. Statistical machine translation. It is a translation model for each word in the source language, the number of necessary words in the target language, the position of the translation in the sentence, the number of words that need to be generated from scratch. You can see in this example, first one is translating word, then translation occurs, then processing, then there is distortion, then you can see the final. The second application, information retrieval. Your input will be a collection of documents, usually from the web, a corporate document collection. A user need represent. So you're giving some query and you're retrieving the content, the output of the collection that satisfy the user needs. See, always the information retrieval, it is not 100%. So information retrieval, query and the document, we are representing same how the document, then comparison, we are comparing the query as well as the document. So if it matches, it will be retrieved. Information retrieval types of information, it can be text, speech, structured information, query language. The matching can be exact or approximate. The different kinds of information needed, sometimes it may be loose, precise and relevance. Usefulness of the information, always it is at the end user, always it is with respect to the user needs. The user can decide whether the retrieved information is exact or relevant or precise. Next application is question and answering, Q&A. We call it as Q&A, frequently performed sequentially. Question processing. So when there is question processing, relevant information retrieval of relevant documents is done. Segmentation in passages, IR information retrieval of relevant passages, and from that answer is extracted. Automatic summarization, it looks for the relevant parts of a document and produces a summary of them. It's a difference between summarization and information extraction. In information extraction, what has to be extracted is defined a prior. I am interested on this, look for it. Whereas in summarization, it is a prior definition of what is relevant is not always defined. See, in information extraction, always we know what we are interested in, and based on that only we will pass the query. Based on the query, information will be extracted. Whereas in summarization, it is a prior definition of what is relevant, and it produces the summary of what is required. Automatic summarization, where we have a multi-document and a single document. You can see here multi-document and the single document. We are giving a query. All together, multi-document, single document, and query will be summarized, and based on this, it will extract, abstract, and headlines. We have some rules. See, this restriction is nothing but the property should not change. The operation happening. See, multi-document, single document, and query put together summarizes to extract. So the final output will be the extract, abstract, and the headlines. Information extraction, extracting useful information from free text. MUC, ACE, TAC challenges. First, named entity recognition, named entity classification. Both the tasks together we call NERC. Slot filling, relation, extraction. So both together, NERC, named entity recognition. You can see here, Jim bought 300 shares of Acme Corp. Jim will be person, 300 will be the quantity number, Acme Corp is organization. You can we need to annotate in this manner. In the second, you can see Jack London went to Paris. Jack is the name. Paris is the place. Paris Hilton went to London. Paris is a place. Uh, so we need to prepare data for named entity classification. See, basically what we are doing in named entity classification is we are going to mark based on the type of data. If it is a person, we are going to classify it as person, location, organization. So we are going to map the data. So next is human machine communication. So the main goal is it helps user perform specific task according to their objectives. The task of the dialogue system: interpreting user intervention, dialogue management, generating system intervention. Hmm. Advantages of using the natural language mode. Human language, natural and friendly. Complex ideas can be expressed. References to other entities are easy to express. But whereas the disadvantage is a high cost, a lot of mistakes can happen due to different ambiguities, limitations for accessing several applications such as graphics. It is appropriate for occasional access to applications that need to express complex operations, especially when there is domain restrictions. An example of conversational uh, system. Welcome to the information service. The system will ask, what do you want? User, I want to go from Barcelona to Valencia. The system will, based on your input, the system will respond, when do you want to go? The user, based on the input, the user will give input next Tuesday. The system will produce at what time, morning or afternoon. See, it is a conversational system. You try to, or it is as simple as Google Assistant. When as simple as a Google Assistant. So since we are running out of time, I'll skip the slides. We'll maybe in 5-10 minutes we'll take hands on. So the last and most user-friendly applications using NLP is chatbots. Uh, Usually, what happens is uh, there will be user whenever we there is any communication. Always it is with respect to two users between human between two human beings. This chatbot
I request the participants to wait for a few minutes. Again, there is a problem at Chetan sir end. He'll join. Please wait for a few minutes.
Hello. Hello.
Yes, sir. Tell me, sir.
Hello.
Yeah, Chetan sir, please tell me. Hello.
Madam.
Yes, sir. Raghunandan is presenting,
Yeah,
right?
yeah. Raghunathan will present, madam.
Okay.
He'll take lead with the hands-on session.
Yes, okay, sir. Yeah, Mr. Raghunandan, sir, you can continue.
Okay. Um, yeah, here hands-on with the Python. So in the Python, actually, if we want to install anything, means I think any library or NLP. So I think the most of the researcher will be go through the uh, Anaconda, or else you can download the packages when we are working, because in the Anaconda we can get it. I think the most of the libraries, like, and it is also open source, and then we can also easily manage the environments. And here, if we want to work with, and if we want to build a model, we can go with a spider, and then here this will be a numpy package. And then also here in the new Anaconda package, we that they are installed, I mean they are added TensorFlow, and then PyTorch, and also I think Jupyter also they have updated. So I think the most of the researchers will be use this Anaconda because it have the most of all the packages. It covers all the packages and also updated libraries in the Python. So I think better we install when we are working with any data scientist or machine learning or in deep learning. I think better to install this. I think this will be very convenient to work in Python. So see, Dr. Chetan has explained how the NLP will be, I mean, I think in the real-time scenario, how we can use the NLP and all, right? So in that, I am taking one use case for an hands-on. I'm taking just in one use case. That use case will be fake news classifier using LSTM. The LSTM means long shutter memory. So in the LSTM, how we can learn means it will be learn using a sequence to sequence learning. And then here, I think I'm not going to in depth about the LSTM, because I think even LSTM itself only it will take in 2 to 3 hours for an explanation, and then how it will be work, how we can tune the parameters. I think what all are the things inside the LSTM, because before the LSTM we need to go through the RNN, the many I think deep learning models are there. So here I'm just go through the hands-on within a small use case of fake news classifier. So if you want to download, actually I'm using the dataset from the Kaggle. So you can download the using this link. So here I'm using this Jupyter notebook, because this Jupyter notebook, it will be very helpful as to work in line by line code, and then also it will be very useful to debug the code, and then if you want to see any output, okay, so this will be very helpful. So I think better to use a Jupyter notebook instead of going to, with an preparing the model. Better we initially we will start with an Jupyter notebook, and then here this will be, we call it as in cell in the Jupyter notebook. So here I think you can go through any website how we can use the Jupyter notebook and all. So here I think I'm importing the pandas, okay, because the pandas will be work like in data frame. Okay, if we import, if we want to import an CSV file or a text file or an Excel, okay, you can go through the pandas, because I'm not going to touch any pandas or anything. Here I'm how the, I think how we can do the I mean classification of the text data, because even we all know I think the computer can understand the numbers, right? So if we give any input as in text, so we need to convert that into a numeric. So then only if any features in a raw text we cannot able to understand, only human can understand it, right? So let's see how we can do the process, and then how we can train with an LSTM, and then how we can do the classification. Okay, so here we are reading it. Okay, here I have kept the training.csv file. Okay, training.csv file in this path. So I'm reading this training.csv file from this path, and then I'm storing it in a variable. Here, if it is shows busy means it is still reading it. Okay, once it has, I think if it is, if, yeah, it has completed, so it will be looks like this. So if you want to see what things are in that data frame, okay, now we have read the CSV file and then we have stored it in an one data frame. So if you want to see what, I think what we have read from the CSV file, if you want to see that one, so you can use the def.head, or else if you want to see some, I think 10 rows, okay, you just give, okay, head of 10. So you can go to this here, see, we can see like this. Or else if you want to see at the end, okay, the last 5 records, you just give -5. So here we can see like this. Then here drop nan values. I mean, this will be like in some noise. If any rows will be empty, or if any, I think rows has contained any, okay, not an integer values like that. If you want to, because that noise will some when we are going to training, so that time that noise will lead some errors. Because of that, we need to do some pre-processing. So I think here how much of we do the pre-processing in any data, so that will help us to train, and then we can get a very good model. I mean, like a stable model. So that will help us to do the prediction or in classification, or if you want to do recognition, anything. So the most of the researcher will be spend the time at the time of noise removal, right? If we get in the data, I mean the clean data, so that will help us to train the system, and then we can get it. I think we can use that for a prediction and also classification, okay, for a different application. So the most of the time will be spent at the for an only the cleaning of the data. So once we have, if the data has been cleaned, so it will help us to, I think we can use an whatever the, if we want to use in deep learning, or if we want to use in traditional classifiers, okay. So the I think the thing means here we need to work more on the cleaning of the data. Here we are getting then independent features here, because see here we can see there are 1, 2, 3, 4, 5 columns are there, right? So I think the most of are aware of when we are training with an classifier, okay, we need to feed and label separately, and then we need to feed a features separately, right? So because of that, here what we are doing, we are taking features, I mean the what we need to process the columns, so we are taking that one as in separately, and then label as in separately. So here in the X variable we are storing the information like in sentence, okay. The natural language processing means in this example this will be an author, title, text. So we can consider here text or in title or in author. So we need to think which column we need to select. That will be explained in the later. So here I'm reading the, I think I'm separating the labels, okay. Sorry, I'm separating the this independent feature from the label, and then also here, okay, here I am storing the label to a Y. If you want to see, check what is the shape of the feature here. Totally 18,285 85 rows are there. So in natural language processing, we are treating the rows as in documents, okay. Each row it represents an document. So then here the 4 indicates totally in X variable it have in 4 columns, okay. So this one is 1, then 2, 3, and then 4 columns. In here you can see here y.shape. This shape function will be written what is the shape of the matrix, right? So in the Y column we can see here this will be in only a single column. So then Here I'm using TensorFlow. I think we know that why we are using the TensorFlow, because in the, I think if we want to, it will be very good for scalability. Okay. And then also when we are working, the most of the researcher will be use the TensorFlow, because of if you want to use any I think GPUs and all, so that will be working. We can easily work with an parallel processing and all. It have an more I think more a good capability of an, I think it consumes an running time and all. I think if we have in very good GPU machines, so I think this TensorFlow will be help us to train the machine learning models or deep learning models in a very faster manner. So here I'm reading that one, and then also this will be, if we want to check what is the version of this, I think TensorFlow. Okay, so if we give like this, so we can get an TensorFlow version. I'm using the TensorFlow of 2.1.0. So here, actually here we have importing what things we need to do the process. Okay, or if we want to train this fake news classification documents. So at the time of here, I'm working with an embeddings. Okay, embeddings means here each word have an some features. Okay, features means it will be in numerical values or real values. So we are embedding that some sort of I think the values to the each word. Okay, so at the time of when we are training, so that will be helpful us to train it. And then I'm importing this padding sequences, and then sequential is for an the layer. Okay, if you want to build in the layers inside that LS stream, so I'm importing this sequential. And then the one-not coding means we know that how to do the one-not coding. So I mean, if any sentences will be, I think if we 2 or 3 sentences are there, so how we can do the one-not hand coding. And then I'm importing this LS stream, because I think the LS stream will be a very good I think model for in a deep learning model for in learner sequence to sequence. And then the dense will be, I think I will explain it how the dense will be work. So here vocabulary means here the set of words. Okay, how many, I think if we consider the corpus of the documents, so here we can see here the corpus of the document will be 18,285, right? So overall we need to think how much of words are there. So we cannot able to consider all the words, right? So we need to do some pre-processing. I mean, we need to do an stop word removal, and then we need to I think do lemmatization. Okay, and then also stemming, because that will be I think if we remove all those things, I think if we consider I think most prominent words, so that will help us to classify the documents or in do the prediction. Okay, so for that, here I have defined that vocabulary size as in 5,000. Here I'm making a copy. Okay, here I'm making a copy of the x variable. We know that in the x, what is there? In x, we have in the information of these 4 rows. 1, 2, 3, 4 rows. Here we are making a copy of the x2, and then we are storing it in another variable as a message, because we need to do the one-hot representation. Okay. So here, for example, okay, we are taking the first column. See here how we can represent, because once we have considered that one as a matrix, so we need to, I think here I'm showing the first row. Okay, first row within title column. See here. See here, the one represent, okay, in the title column. This will be stored, the whole these 4 columns. I think this this frame has been stored in a message variable. And then if you want to see this, okay, the first document we need to give 1, or else if you want to see 0, you can see here. And if you want to see, if you want to check, I think till I think 18,000 to I think 85, right? Yeah, this will be the last document. Okay. So like this, I think if we want to check anything, so that is what this Jupyter notebook will be very helpful for us to check. Okay, what things will be happening. Okay, and then here I'm resetting the index. Okay, see, after resetting the index, if you want to see,
Swathi Reddy. Hello, Swathi Reddy, please mute yourself.
here,
Okay, otherwise we will do it.
see here, after reset the index, so the index column will be added. Okay, separately, that will be index column will be added. Previously, only 1, 2, 3. See here, this is the what inside this message we have take a copy of that X variable and then we have stored it in a messages. So here we can see how it looks. So here I'm using an NLTK library. Okay, this will be the I think a very good for an I think the most of the researchers, I think the most of the I think pre-processing and then whatever the things we need to do in the NLP. So I think this NLTK, I mean natural language processing toolkit. Okay, it having that capability of I think most of the things we can use with this NLTK. So better to consider, and also we have in Spacey, okay, and also we have in Ginsem, and also we have in text blob. Okay, so I think here I'm taking that NLTK toolbox for an I think do the pre-processing. Okay, this will be an if you want to do any regex or something, okay, regex pattern, if you want to create it, okay, we can import this one. And then here NLTK corpus, in this I am taking that stop words. Okay, you know, I think we all know about what is stop words, right? Right, here stop words means I think I will show that example. I think I have not included here. The stop words means if any sentence, we will take an example of this sentence here. Okay, so here I think here see this on, okay, on, and then if it is in a stop words means it is like an the and then a and thing like that we need to, or else NLTK itself have an inbuilt stop words library, or else we, if we want to include some more, we can use it. Okay. Then here I'm importing the stemming. Actually, I think Dr. Chetan has touched how the stemming will work, right? Stemming, lemmatization, and all. So here, why we need to do stemming? For example, if we take an example of going, okay, and then somewhere we will write in some in some text that will be taken go, right? Somewhere wasn't is there, somewhere was is there. So when we are doing that stemming and then lemmatization, so that will help us to I think remove the I think the stemming the words, and then we can get it in unique words. And then here, see here, this, okay, this will be used only we need to consider the alphabetics like in A to Z in the small letters, okay, and then if it is in capital letter we need to consider only the alphabetics. If any special characters or if it is any numerical values, okay, or if any special characters, okay, we need to remove that one before feeding this to. I think we need to do the lot of pre-processing, and then here we are doing in lower each sentence. I mean here if you take in each document, okay, if any sentence, how much of sentence are there, we are doing in, okay, we are doing in lower means we are making, if it is an uppercase and then lowercase, we are taking in only the lowercase. So that is what we are applying. If it any capital letters are there, we are making that one as in lowercase. And then split. Here split means we need to work with and splitting the in a sentence. Okay, at the end, if it is in any full stop is there, we need to split that sentence. And then here we are working with an stem. Each word, okay, each word in a corpus, it will be check the each word and then it will be do the stemming. So here I'm printing it, how much of documents are there, okay, and then also how much of words it is going to do in a corpus, okay, and then it will be stemming and then it will be append to the corpus. Here I'm using this corpus variable and then it is going to append to that corpus. So we need to wait for this cell execution completion. Because it have totally 18,285 records. In that, it is an checking within each word. So it will be an huge corpus. It's I think it is. Yeah. This cell has executed. So I think we can see I have printed here totally. Yeah, totally 18,000 because it has started from the 0 and then here 18,285 documents are there. So in that documents, it has, I think, pre-processed. Here I'm using then limited pre-processing. Here I'm removing the special characters and then the numerical values, and then I'm doing then lowercase because to maintain the uniformity. And then here I'm using the splitting and also stemming the each word in a each record or in document. And also here we are using it as in stop word removal in the English. Or else I will give a small example. Wait, I'll just copy this. I want to see what all are the stop words. Here, these are the stop words. I think if you're not aware of these things, you can understand. These are the stopwords. It will be in the inbuilt. I think when we are using the NLTK toolbox, so we can just import like this, and then we can use it. See here, you can see. I think here they have. I think if we want to add any, I think a stop word, okay, because I think the many are working in different contexts or different use cases. So if you want to remove some other stop words, if you feel okay, this will be added to stop word, then you can easily add to this one. Okay, you can add like you can take set of the what is that stopwords, and then you can use an union of that one, or then if you add it, so that will also add it to this corpus, okay, STP, and then you can use that one for an pre-processing. Okay, then here this will be an pre-processed. See here, you can see how this will be in lowercase. I think all the words will be in the lowercase, and then the I think there is no special characters. I think if you want to see this, you can just check within first sentence. I will copy that. Before that, I will show this how pre-processed, and then this will be looks. You can see here this one. Here we can see how the first, okay, for example here how this has been. See, this will be stem, okay, house, because that will be depends on the toolbox what we are using. Or then if we want to do I think separate stemming, means we need to write our own algorithm. Here didn't, this will be treated as an stop word. See, this V is treated as an stop word, and then this C it came, and then here this as, okay, this as in stem, okay, okay, we have used the stemming, so that, and then here at the end it, okay, this will be treated as an stop word. So in the same way, if you want to check, okay, each record, you can just check it like this, okay, what's happening here. So this will be an special character here, okay, so that has been removed in the pre-processed document in the corpus. And then here one-not representation. Okay, here we see how one-not representation means in the each each record we need to check, okay, how many times this word has been repeated in the document, okay. So and then we are doing in like that, we are doing in one-not coding representation here. So and then here also this one has an embedding representation. So if you want more detail about how we can use a word embeddings and all, you can go through I think website. I think better to go through some I think Kaggle examples, or in some any GitHub resources for an how we can work with an embedding representation. Because if you want to do our different contexts, different words are there. If you want to create in word embedding representation, so we need to work with an padded sequence. Okay, sentence length will be 20, and 20 means totally how many words are there in a sentence. So we need to, I think this will, here I am using 20. So if you are working with different use cases, you need to change here. Okay, that will be depends on the use cases, and then depends on the applications. So then here I'm using that maximum length as n. I think for each, okay, for each word we are doing an, what is that, the embedding representation. Because in LSTM, we need to, I think we need to, if we want to train anything, means we need to prepare the data like this. So for an first document, see here, we can see, okay, this will be an embedded documents. We can see here why these all are 0 means the total length of the each embedding document will be 20, right? So maybe in the first till here 2, 4, 6, 8 and then 10, okay, here there is no words. I mean, that will be depends on how here when we are doing the 1 or 10 coding. So I think this will be, these words will be started from here to here. Then here we can embedding vector features. I think someone has raised a question like what is that stemming lemmatization both generated the foundation sort of the inflected. Okay. Here the vectors are used under the hood, find the word similarities and then classifying text. Actually here for this deep learning technique I'm using it. Okay, if we want to do any what is that a machine learning or a traditional classifiers, if you want to use SVM classifier or KNN classifier, okay, so for that actually I will share some other code. Okay, at the end of this I will share that code, because here also I think here, yeah, I think we need to use term frequency and then inverse document frequency in this example, because why I'm showing it, because someone has raised the question like we need to use an word similarity like that. So I think the document how we need to know that. I think if you want to going with an deep learning, how we need to represent the data. Okay, so here the most of the deep learning will be working within this embedding. Even here the one more, the I think popular NLP deep learning model is in bidirectional encoding representation transformation. Okay, so in that also there I think we need to work with and how we need to prepare the input data. So yeah, here in this I think when we are working within some traditional classifiers, so here I'm working with an TF-IDF transformer. So count vectorizer means here we need to work within bag of words. Okay, so then the bag of words we need to convert that into a TF-IDF vectorizer. So then the each vector will be associated with an label, and then we need to feed to that traditional classifier. Okay, here there are I think many things are there in the machine learning and then deep learning. We need to work within parameter tuning. Okay, so if you want to select, and I think if we want to select an best parameter, again we need to go within grid search CV. Okay, so I think we cannot able to tell, okay, this I think what I have defined that hyperparameters will be I think best, and then that will give them good accuracy, or then that will be given in very less validation loss or something. So we need to do in a lot of trial and errors, and then we need to take in empirical results for n to set a hyperparameters. So here I'm using in binary cross entropy because I'm using only 2 classes here. Okay, so here, okay, this will be vocabulary size will be 5,000. So initially we have I think totally it will be considered, and 5,000 means 5,000 words, and then embedding vector features, and then input length will be sent. Okay, so each, okay, the vector size will be and considered as an here the input length will be in, each sentence length will be in 20, but here the input feature vector will be in 40 here, and then here I'm taking in 100 nodes here, and then the activation function will be used for in sigmoid here, because here I'm training within less data. So and then also I'm using in only one layer. So here when we are using this, if you want to see, okay, in how many layers we are using, how many parameters are there, okay, what is the trainable parameter. So if we use the summary, the model, okay, so once it has been compiled, so this will be stored in the model, and then we can see, okay, here if we print this model, we can get it here. Length of the embedded document size same, and then this the y dot shape will be in this one, because in the y we have in labels, we need to feed and label within feature vector. So here this numpy will be work for n if we want to convert the feature vector into an arrays, I mean matrix, because this initially this data type will be, if it is data type will be in a different data type, so better to be work within I think numpy. So before training, we need to split the data. Okay, I can point. I think like in 33% of data I have considered as in test size, and then the train data size will be remaining will be the train data size. So in the scikit-learn model, we can get it then train and then test split here. So here, for training the model, we need to feed within feature vector and then the labels and then validation loss within x test and then y test. And then I am using totally number of epochs will be 10. So batch size will be 64. It's still.
Raghunandan sir, just epochs are running, no?
Yeah.
Okay. Is there anything to say? To
Yeah,
conclude the
nothing.
session?
Nothing.
Just accuracy to be, here we are getting the accuracy.
Yes,
based on the
because
epochs
it,
are going
yeah,
up.
validation loss will be when it will be come to the stable. So that time it will be, because I'm using 10 epochs, so we
Yeah,
need to check with
50
an.
is running. Yeah, 51
Yes.
is running.
Yeah.
Okay, actually we need to close the session by 11:40. Next speaker is as waiting.
Okay.
Yeah.
Okay.
Conclude the session. Just conclude the session by
Okay.
giving the summary.
Otherwise, I will share this what I have written the code.
It
Okay.
will be very happy if you share the data set to our participants so that they
Sure.
will ask-
Sure. I will share.
Already some people are asking for the same.
Yeah.
For the data set.
Yeah. I will share this. Okay.
Share the data set as well as slides used for the presentation.
Okay.
Thank you very much for your practical demo.
Okay.
On the specified topic.
Okay.
Thanks Chetan sir and Raghunandan for sparing your time.
Sir. Yeah.
For
Thank you.
sparing and giving the insights to our participants. Thank you. Now the second session will be started by Dr. R. Rajeswara sir. I welcoming you, sir. I have seen you are joined at 11:25 itself. Thank you, sir.
Yes, thank you to Dr. Chetan and Mr. Raghunandan for sharing your knowledge with the participants. That's about the session on NLP using deep learning. Now we have the talk about deep learning for speech processing. This session will be given by Dr. R. Rajeshwar Rao sir. JNTU Kakinada, University College of Engineering, Vijayanagaram. So we welcome you, sir, to this AICTE online STTP on machine learning and deep learning techniques, sir. A very good morning to you, sir, Rajesh Rao, sir. We welcome you. And before I hand over the session to Rajesh Rao, sir, let me introduce him. Dr. R. Rajesh Rao, sir, is presently working as a professor in the Department of CSC, University College of Engineering, Vijayanagaram. Dr. Rao completed his BTech in CSC from via Siddhartha Engineering College, Vijayawada, MTech in CSC from JNTU Hyderabad, PhD in CSC from JNTU Hyderabad. He did postdoctoral research from University of Missouri, Columbia, USA. Dr. Rao is having 19 plus years of teaching experience in the field of CSC. Dr. R. Rajesh Rao, sir, served as officer in charge of hostels and head of the department, JNT Kakinada, University College of Engineering, Vijayanagaram. He is expert visit committee member to AICTE New Delhi. He is a state level committee member for curriculum development for the state of Andhra Pradesh, appointed by AP State Council for Higher Education for CSC. Dr. R. Rajesh Rao, sir, authored one monograph titled with Automatic Text Independent Speaker Recognition using Source Feature, and two textbooks titled Cloud Computing and Virtualization, Software Engineering, a New Approach. 4 students have received PhD under his guidance from JNTU Hyderabad. To his credit, he has published papers in ACM, Elsevier, Springer, and other reputed journals. Dr. Rajesh Rao, sir, authored 76 journals, presented papers in 35 conferences, and chaired 23 session chairs, and gave 43 invited talks in various reputed colleges in Andhra Pradesh and Telangana. Professor Rao received Dr. Abdul Kalam Award for Teaching Excellence in 2019 from Marina Labs, Chennai. And Professor Rao received Best Researcher Award from JNTU Kakinada in 2018. And also he received Vidyaratan Award from New Delhi. He is an academic advisor to National Cyber Safety and Security Standards. He is also a member of CSI and senior member of IEEE. His areas of research are artificial intelligence, speech processing, pattern recognition, NLP, and cloud computing. On this note, with this long list of achievements, I welcome Dr. R. Rajesh Rao, sir, to take over the session. Sir, you can continue, sir.
Madam, am I audible, madam?
Sir, audible, sir.
Yeah, thank you for your nice introduction, madam.
Thank you, sir.
Very good morning to all of you, Dr. Srinivas Rao garu and other panel members. It's a privilege to be a part of this AICTE STTP program on machine learning and deep learning techniques for artificial intelligence. So even I have good, before joining in here in JNTU, I was in Hyderabad. I think majority of you are much aware of me. So it's good occasion to be here to associate with you as a resource person on this good occasion. So anyhow, let us switch over to this content. So am I audible, madam? Shall I continue?
Sir, yes, sir, you're audible, sir. You can continue the session.
Right. Thank you. So my talk will be on automatic text-independent speaker tracking system using deep neural network. So mostly I will be covering on the speech content and how we have used deep learning concept regarding this application speaker derivation. So actually this is one of the work which was done by one of my scholar and submitted to JNTU Hyderabad. So he was awarded his PhD last year. So his complete work I'm going to present here. So I would like to present the concepts when and there whenever it is related to this deep learning. I will emphasize on that, and you just go through it. So see, as you are aware that speech is one of the prominent area where a lot of research is going on. So if you take the Indian context, we have, our country is a multilingual country where because of due to this main emphasis focus on artificial intelligence, we are developing a lot of AI based system with respect to English. But as a country, a developing country, we have 60 plus languages in our nation. So where much focus is required and a lot of funding is available and much contributions are taking place in this particular area. So in that process, my talk will be mainly focusing on this speaker derivation system. So actually, what is speaker derivation? What are its applications? Where we use? So all these things that I am going to cover here in this talk. So so this is the outline. So as you are pretty much aware, majority of the research scholars and learned scholars are there in this. If I go through the participants list. So literature's introduction, literature survey, problem statement, and then research methodology and contributions. So results and discussions, and I am going to give the conclusions. So actually, what is this speaker tracking or speaker derivation? What are its applications? So what are the challenges with respect to this speaker derivation? And what are the phases of speaker derivation? So, you know, the speaker derivation is nothing but who spoke when. See, there are many applications with respect to speaker. So we can see, if you take a speech sample, we can there in that speech sample, say for example, I am talking now, in that speech, a lot of information is there. For example, you can think about language content is there, who spoke, speaker content is there, gender content is there, age content is there. Okay. So likewise, text content is there. So likewise, in this speech sample, a lot of information is embedded in that particular signal. So the beauty lies in what content that we are looking for. Are we looking for a speaker? Are we looking for language? Are we looking for say some content? So on and so forth. So here, sorry. Our focus will be on speaker derivation. So if you take a signal, I think majority you people might be watching TV channels, debates with respect to NDTV or with respect to ETV or some other channels, local channels. So there are where you can observe that say some 3 to 4 participants will be participating and they will be giving their views or insight towards a particular topic. So in that, where we can find say some 3 to n speakers will be there. So here our objective is how many speakers are there and who spoke what. So that is the major definition for speaker derivation. So speaker derivation means it is the combination of speaker segmentation and speaker clustering. See, for example, here in this figure, you can observe that, see, there are 4 speakers, speaker 1, speaker 2, speaker 3, and speaker 4. So see, the speaker 1's speech is up to this particular point. What the function of this is segregating one speaker to other speaker, we call it as speaker segmentation. So then followed by speaker 2, speaker 3, and speaker 4. See, there is no, see, this is a sample which I have shown you. This slide depicts that number of speakers and their segmentation. So what is the objective of this clustering? See, if you take a speech signal or if you take a debate, if you visualize the general debate that takes place in TV debates. So speaker A will be speaking, followed by speaker B, again speaker A, again C, again B, again D, again A. So A will be coming on and off. So here A will be coming on and off, B will be coming on and off, and so on and so forth. So here, what we are going to do here is, so here we what we do is here. Excuse me, 1 minute, Andy. Hello, sir. Sorry. So here, what happens? Here we are supposed to think about who spoke when. So continuously, the speaker A or speaker 1 will be on. He will be coming on and off. So in order to gather speaker in that, if you take entire speech signal of say some 30 seconds or say some 2 minutes or 3 minutes, speaker A will be there at 5th second to say some 30 seconds and 60 seconds to say some 80 seconds. So this first we are supposed to segment it and we are supposed to cluster it. Okay. So that is the, it illustrates, this slide illustrates the segmentation and clustering. See, for example, here, this particular speaker A, speaker 1 may come after speaker 3. And after, speaker 2 may come up after say some speaker 3. So each speaker's data has to be brought at one place, and that information has to be clubbed, and we are supposed to do some clustering process. So what are its applications in today's digital field? So these are all the major applications with respect to speaker direction. One is broadcast news archives. So see, for example, a lot of digital content will be there, and I am supposed to archive speaker A's information, content, or speaker C's confirmation, the data which is there in the database. So this application, speaker direction application, will be pretty much useful in these particular applications called as broadcast news archives, telephonic conversation. So especially with respect to digital forensics, these days, police people are much focusing on the mobile phones, and so they are able to identify the culprit based on their speed, by using the phone tracking, and also by going through the content what they are speaking. So telephone conversation, recorded meetings, so used as pre-processing tools for auto indexing, speaker identification, speaker verification, tracking. So these are all the applications with respect to this speaker tracking, right? Speaker tracking, or in other words, we can call it as speaker direction. So what are the challenges here with respect to this speaker direction means? So there won't be, see, if you take a signal, if you take a recorded signal, we won't be having how many number of speakers are there. We don't know what is their identity. So this is one of the major challenge with respect to this speaker direction. Next thing is feature extraction. See, feature means extracting relevant information related to that particular speaker. That is one of the major tasks. So extraction of relevant features or acoustic features to determine the speaker and their corresponding locations. So the third one is mainly focusing on extracting speaker related information in the form of feature vectors. So see, earlier I think you might be aware of the scenario related to Mldlt. So he used to release audios on and off. So when there is an audio, so entire nation, the United States, they used to think about whether this audio or speech is related to Mldlt or not. So in such type of circumstances, these applications are very much useful. Okay. So these are all the challenges. So actually, what are the various phases in this speaker direction? See, if you take the speech signal, see, the speech signal looks like this. So content will be there. There will be some sort of pauses will be there, then followed by some pause, speech content, then pause and speech content. So what we are supposed to do, so this speech signal consists of information pertaining to speaker here. So our objective is to extract speaker relevant information. So when our objective is to extract speaker relevant information, our emphasis or our main focus will be on extracting the relevant features related to this speaker. So as I said, the extracting relevant information from the speech signal is nothing but feature extraction. So this is how we extract it. And the next phase, what we are going to do is we are going to segregate the features which are relevant to speech, I mean information related to speech content, and which is wherever speech is not there, we will remove that content. So these non-speech areas, we will remove it. So if you look at this, see this here, these black spots, high density black spots indicates speech content. So wherever speech is not there, there you won't be finding these feature vectors. Then speech activity detection, then followed by speaker segmentation. See here 111 is there. So this 111 reflects speaker 1. 2222 reflects speaker 2. 3 third speaker and fourth speaker. So similarly, what I have done was, we have clustered it. So the entire information related to speaker 1 is gathered at one place, which we call it as, which we have given it as A, B, C, and so on. So finally, by adopting this procedure or methodology, we are going to get speaker A. 4 speakers are there in the given speech signal. So hope I think you people are following. Please let me know if you find, if you feel, just raise your hand so that, or if you can abstract me during my presentation, so that whenever there is, when and there, if any clarifications are required, I can clarify it, right? Then coming to, so this is the literature survey that we have gone through while performing, while carrying out this project. I think you can go through it. So what is the problem statement? Means, as I said, recognizing the number of speakers from the given speech signal and identifying who spoke when. So in a broader perspective, the block diagram for speaker derivation or speaker tracking looks like this. Okay. So what is the research methodology that we have adopted was, see, as I said, from the speech signal, we are supposed to extract the relevant, we are supposed to do the routine process, which we call it as pre-processing, then followed by feature extraction, then speech activity detection, followed by speaker segmentation, then I vector, then speaker clustering and indexing. So here, the major task, the major emphasis has to be taken care here in this particular point: speaker segmentation and speaker clustering. So these two are the major areas which reflects the performance of the speaker tracking or speaker derivation system. So here in this particular point, particular phase, speaker clustering, we have used the concept called as a deep neural network when compared, than the other existing works which we have done, so that we could able to identify, we could able to get some good recognition performance. So, see, as a routine procedure, in order to carry out any research work, we should have some motivation related to this particular, task. So here, energy component is one of the major tasks which we are supposed to look into, and the second one is the frequency component. So after going through the literature survey, our observations are like this. Several studies have shown that the frequency response of the spectral features with the good clustering approach will give good recognition performance in speaker derivation system. So as I said, if you take, say, some 1 hour speech data, where, say, let us take that 6 speakers are participating in the debate. So as I mentioned earlier, say, for example, second speaker will be, out of this 1 hour speech data, second speaker will be participating on and off in the entire 60 minutes speech duration. So what is my task? I am supposed to gather the entire information or collect entire information related to speaker 2. So that process is nothing but clustering here with respect to the speaker derivation. So if I can perform that task perfectly, then we can say that our speaker derivation system or speaker tracking system will give a good recognition performance. So that is one of the major factor which motivated us. The second one is, see, of course, it's a big, area where we are supposed to concentrate related to features, whether we are supposed to go for spectral features or whether we are supposed to go for prosody features or for source features. So here in our experimentation, what we have done, we have considered spectral features. So the other name for spectral features is system related features, our vocal tract features. So here the energy, the limitations are energy levels. So the more the energy level, the more the accuracy will be there. So when we have extracted features, so this is one of the implication factor which influences the recognition performance. So in view of that also we have taken that. This is one of the major things. So in order to overcome, we propose spectral features with the good clustering approaches. So finally, so what we have done was a major focus is on clustering, another one is related to the features. So let us, we have done 3 contributions here. So let me explain one by one so that you can have some clarity over it. So still now, I will be happy if any one of you can, if any one of you have any doubts, please let me know so that I can move forward regarding the contributions related to these clustering concepts as well as these features. So I will be happy. So please, any of the participants, they can ask any queries related to this particular concept.
Yes, sir. Chandia ma'am, do you have anything to say?
Ma'am, no, ma'am.
Okay. Sir, excuse me, sir. If you don't mind, can you keep the slides in full screen mode, sir?
Full screen.
Yeah. This PPT, I think you didn't downloaded it, so maybe.
Yeah, madam. Is it okay now?
Okay, sir. But
Right,
okay, yeah, okay, sir.
1 minute, I will share it. There is some problem with the screen share, right? Are you able to see, madam, the screen?
Yes, 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 yes,
Hello, Revati, madam. Hello.
yes.
Is there any problem? Are you able to see the screen, madam?
Yes, sir. Now you're not presenting, sir.
Yeah, 1 minute. I think there is some problem with this. sharing. Is it clear, madam, now?
Sir, directly can you go to Sir, please go on like this, sir. Please go on like. Sir, please go on, sir.
Yeah, madam. So these are the three contributions. Contribution one is we have proposed tangent weighted Mldlt frequency substral coefficients using line optimization clustering algorithm. So as I said here, more emphasis in this work is on two phases. One is on features and other one is on clustering. So you people, I mean, people who are aware of this speech processing or speech content, speech subject, they will be aware. The basic feature extraction technique is MFCC, male frequency substral coefficient. So in addition, I mean, apart from this MFCC, we have proposed this tangent weighted Mldlt frequency substral coefficient feature extraction using a line optimization algorithm. The second contribution is multiple kernel weighted Mldlt frequency substral coefficients, that is MFCC. And the clustering approach that we have used is Woolley clustering approach, Woolley clustering validity index. And third one is, this is the major contribution which is relevant to this particular being STTP program, that is all-out entropy with extended linear prediction using autocorrelation snapshot, that is HX LPS method using deep neural network. So we have carried out these three experiments with respect to these three contributions. And what we could able to observe was this third contribution by using this deep neural network with respect to that particular clustering approach. By using this hollow entropy with extended linear prediction, we got good recognition performance. So of course, this was published in Springer Journal. So let me explain you about the overview of this contribution one. So what we do, see, if you look at this particular block diagram, so here data set is there. So as you all pretty much aware, you take any data set, what we do is the first and foremost important task that we perform is pre-processing. Then we extract a feature extraction. So that if we extract substral features, this is the general routine procedure which we adopt for extracting features. So what we have done, as I said, the first contribution is focusing on tangential weighted function. That means TMFCC, tangent Mldlt frequency substral coefficient. So after extracting these features, we have performed this voice activity detection. So as I said, as I have shown in the earlier slides, if you take the entire speech signal, there will be few passes in between speaker to speaker change. So that speakers, are while talking. See, if you observe my speech, there will be certain passes while I am giving my lecture. So this voice activity detection, then followed by this feature vector extraction. Which we call it as I vector. Then this clustering here in this clustering approach, we have used this line optimization technique. So accordingly, we could able to identify who spoke what, how many speakers are there. So this is the block diagram with respect to this TMFCC. So exclusively, if you want to look into this TMFCC feature extraction phase, so this is the input signal, and we pre-emphasize the input signal, and we adopt. We go for framing, and as you all know that we will convert that speech signal to frequency domain. So by applying DFT, then power spectrum, and these are all the MEL filter bank. So we apply a logarithm on that, and we have taken this tangented weighted function of the values which we receive from by applying on this MFCC, and again by using this DCT, discrete cosine transform, we are going to get this 19 TMFCC feature vectors. So what we have done, see, this is the comparison between the input signal and, as I said, the ground truth with respect to this TMFCC. In general, we take MFCC output speech signal. This is the input speech signal. If we extract MFCC features, the amplitude looks like this. So by applying this TMFCC output of speech signal, you can observe the amplitude is much improved when compared with this MFCC. See, the objective of taking or considering TMFCC, that is tangential null frequency substitute coefficient, is in order to give some weight so that the amplitude will be, the amplitude of the signal will be enhanced, and at the same time, the speaker information will be improved, so that in order to, while extracting the features, it will be we will be getting much relevant information with respect to this feature extraction. So, as I said, if you look at the phases that are involved in this speaker derivation system, one of the important phase is speaker segmentation or change of activity. Speaker change detection. That is called segmentation. If you look at the block diagram, in that block diagram, speaker followed by segmentation followed by clustering. So these are all the three phases that are there. So in this speaker detection, when a particular speaker is going to change to, when the second speaker is going to come from first speaker, when the third speaker is going to come from second speaker. So this speaker change detection or segmentation is one of the major phase in this speaker tracking system. So this is how we have performed this speaker change activity or speaker change detection. So you take the audio signal, extract this TMFCC features, Gaussian mixture models, and this Bayes information criteria, we are supposed to extract it. So what we do, based on as you are pretty much aware of it. So this type of task comes under the pattern recognition task. So in pattern recognition, always three phases will be there. One is feature extraction, the second one is training, and the third one is testing. So in order to fix the threshold, we at the earlier stage, we set one particular task, and we repeat the process of training the system. And when there is no change in the improvement of these parameters, we stop the process. So and we say that the system is completely trained, or now the model, whenever we obtain the optimal value related to the particular parameters, we can say that we have reached the required threshold, or we can say that the system is trained. So by using this Bayes information criteria, we fix the threshold, and if the Bayes information criteria is greater than the threshold which we have fixed, so then we say that the voice change activity has taken place. So this is the logic behind this voice change, change of a speaker or speaker change detection. So this is how we have taken this. So Bayes information means we consider a priori probability and posterior probability, and by using these formula, Bayes information criteria X and M. So log of X given M. So log likelihood ratio of the data X in the given model M. So where n is the number of frames in the given segment, k is the number of model parameters or mixtures, or this lambda is nothing but penalty factor tuned according to data. So see, this is nothing but one type of hypothesis. So we cannot fix the threshold as if, see, I cannot simply say that I have taken X point something as, say, X as some threshold, Y as some threshold. Hypothetically, I will fix some data and I train the data and I will train the model at a particular point. Obviously, I'm going to get some threshold, some value. That value, I am going to fix it as the threshold. So this I vector extraction, this is one more important process that is there in the implementation. So this I vector also, after detecting this segmented feature vector, this universal background model. So this is also the enhancement of Gaussian mixture model. So what we do is we take the mean adapted of Gaussian mixture model. As a resultant, we get this I vector. So after getting this mean adapted Gaussian mixture model, we transpose that mean adapted Gaussian mixture model. Because of this I vector, what happens, see, if M is the space and by applying T dot Z, by applying this transpose of this resultant Z, what we get, we here what we do, we are going to reduce the size of the feature vector. So the objective of using I vector is to separate the speaker information and channel variability by reducing the dimensionality of the feature vector. So you people are very much aware of it. So when we extract some certain features, in order to reduce the size of the features or in order to reduce the size of the database, what we do, or when we want to reduce the repetitions of the feature vectors or parameters, we implement certain techniques in order to reduce in order to compact the size of the feature vector. So this is one of the technique which we call it as I vector. So the other beauty or other, important point in this particular with respect to this I vector is we can, by implementing this I vector, or the beauty of this I vector is it reduces the channel characteristics. See, now I am using microphone and I am giving talk. So obviously there will be certain portion of this channel noise that is going to be embedded in this speech or the talk which I am giving. So because due to which there will be certain portion of reduction in the accuracy. So in order to overcome that, after extracting the feature vectors by applying this I vector concept, what we do, we can reduce the dimensionality by removing the repetitions of the parameters, and at the same time, what happens, we can remove the channel characteristics of that particular voice. So that is the beauty of I vector. So that's how we have considered this I vector technique. So the next important phase, as I said, line optimization algorithm. So which is used for clustering purpose. So this is the flow diagram for this. So generate random line population and initialize the number of clusters, calculate fitness. So we are going to calculate the fitness by using this in this process. So if it is true, means select the best two individual parent lines to get to the next generation. Then we apply crossover and mutation. So we repeat this process until we get the perfect clusters. If it is false, means we will go for other option. So select the best solution and stop. We are going to stop the process. So you people are very much aware of these concepts with respect to this machine learning in fuzzy logic. So this line optimization algorithm is used for clustering, in the process of doing clustering. So this is how we are going to evaluate the fitness evaluation. So we will take some cluster K1 and we will evaluate the distance D1 and D2. So whichever is closer, we will assign that particular cluster K1 to that cluster. This K1 to this particular cluster 1, K2 to this particular cluster 2, K3 to particular cluster 3. So the database used for this particular study is English language speech database for speaker recognition speaker recognition. So there are various speaker-related corpuses. Those who are interested or those who want to go to do speech, research in this particular area, they can think about this as one of the standard database, which is ELS DSR, English Language Speech Database for Speaker Recognition, or TIMIT. TIMIT is one of the standard database, these two are standard databases with related to speech corpus. I think even in IIIT Hyderabad, they have developed some database with respect to this Telugu content. See, these work we have done with respect to this English. So those students or research scholars who want to carry out their research in this particular domain, they can consider about that, they can think about Telugu language. So, in Telugu language, IIT Kharagpur have developed some standard database, and even you can record from your own students. See, you take Telangana accent, Rayalaseema accent, and Central Andhra like Vijayawada and Guntur accent, Nellore accent, even Uttarandhra accent, where I stay. So you ask your students to utter same sentence gather information related to these 4 to 5 regions. Obviously, there will be some reflection with respect to the performance of the system. So we can, or even you can think about gathering database with related to ETV Pratidhwani. I think you people might have watching ETV debates or NTV debates or some other TV channels debates. So where there will be 3 to 4 speakers sitting across, round the table, and there will be discussions going on. So you can think about this Telugu database with respect to this speaker derivation. So you can evaluate the performance, you can evaluate the recognition rate and all these things. So with respect to this first point, what we have done, these are all the evaluation metrics that we have considered. One is tracking distance, tracking accuracy, F measure, false alarm rate, and derivation error rate. So see, if I develop a system, the system should work for, it should, the tracking distance, see, suppose if I take 60 minutes of data, if my system is not able to perform tracking for 60 minutes, if I say that if it is working for only say some 20 minutes and 30 minutes, then there is no meaning of that. So these are all the performance metrics that we have considered. So tracking distance, tracking accuracy, F measure, and false alarm rate, and derivation error rate. So accordingly, so the tracking distance is the distance between the original output signal from the system and the output from the various speakers. So this should be more with respect to the accuracy. So this is OIO of YIG. So OIO indicates the original input signal, and YIG indicates the speaker output. So this is calculated as tracking distance. So tracking accuracy defines the accuracy of the speaker derivation system and indicates the number of frames. So this is how we have calculated. So the performance evaluation metrics, you people are pretty much aware of it. What is precision, what is recall, what is F measure. So accordingly, we have calculated. So these are all the results that we have that we got with respect to this first contribution. So we have taken the first frame length as 30 seconds, 60 seconds, 90 seconds, 120 seconds, and 150 seconds. Number of speakers here we have considered it as 3, and this is the existing technique. And the technique which we have proposed is TMFCC plus line. When we compared with this, we got a good accuracy, with respect to the speaker tracking. And when we have considered this number of speakers with respect to 5, so TMFCC plus line optimization technique has given a good recognition. See, the values are less. So the tracking distance, wherever it should be, it is less. That is, we can say that we can claim that it is matching. Okay. So accordingly, this is how we got the recognition performance with respect to these two, tracking distance and tracking accuracy. The third, this is tracking accuracy. So the existing, this is one of the recent published paper. So when compared with this, the proposed approach has given good recognition with respect to tracking accuracy. So the remaining parameters like F measure, we have calculated it for 3 speakers and 5 speakers. You could see that, you can observe that the proposed method results are better than the existing one. So FAR and variation rate, all these values we, somewhat better when compared with the existing systems. So the second one is, the second contribution is MKMFCC, multiple kernel weighted extracting features by using WLI fuzzy clustering. So here, this paper was published in International Journal of Speech Technology. So see, when we propose a new concept, obviously we are supposed to say the drawbacks with respect to the existing contribution. So the drawback with respect to this, drawbacks are what we say are what is the motivation to go for this particular concept with respect to features or clustering. Here, so these TMFCC features cannot pursue frequencies over 1 kHz. See, as you all are pretty much aware that our human ear can hear sounds for a particular, for a certain range of frequencies. So, but whereas, so this TMFC cannot pursue frequencies over 1 kHz as like that of the human ear. So, in order to overcome that disadvantage, this particular proposed MKMFCC features with respect to this WLI fuzzy clustering approach, we have, it has given some better accuracy. I will quickly wrap up this. So here, the limitations of this line algorithm is there is no guarantee with respect to this convergence of the global optima. So it requires higher computational time. So these are the two drawbacks with respect to this line optimization algorithm. So what we have done was we have proposed this WLI fuzzy clustering so that clusters, each data point can belong to more than one cluster. See, the thing is, while doing clustering, there should be specifically, there should not be ambiguity over the points, are the parameter, are the entities to which cluster it belongs to. So that uncertainty should not be there. We are supposed to specifically, certainty has to be there with respect to good clustering approaches. So wherein clustering each data can belong to more than one cluster. So this point is one of the major important things, so that the data point has a degree of membership in each cluster. See what happens, the line algorithm is not able to address the point with respect to the uncertainty, with respect to the entities related to that, members in that particular function. So here membership with respect to high degree, that means there will be a point or an entity which may belong to 2 or 3 clusters. So this probability also considered here to improve the compactness and separation with respect to WLI fuzzy clustering approach. So here the same thing, the same block diagram which we have, which we have performed earlier in contribution 1. So here the additional thing that we have added is we have given in addition to the tangent weighted function, we have added exponential weighted functions here, so that we want to improve the energy component, so that we can have better information related to the speakers. Okay. So the same performance we have, the same things we have carried out. So I don't want to repeat the same. So see here, same thing, pre-emphasis, DFT, power spectrum, MFCC, we have MFCC filter banks, then logarithm, then weighted tangent plus exponential function, which we call it as multiple kernel weighted function, so that we can improve the weights of the parameters so that the energy levels will be enhanced, and accordingly we can get good we can extract information much speaker information in a better way than the existing weighted tangential approach. So here also you can see we have plotted the comparison between the information related to MFCC, MKMFCC, and the input signal for 3 different speakers. So here you can observe clearly. See, I'll try to magnify it. So here, speaker 1, speaker 2, and speaker 3 here, the information so how the by implementing these MKMFCC extracted features output for speaker signal, how the amplitudes are varying, you can observe the difference between the ordinary speech signal and the MKMFCC extracted features for speaker signal. So as I said, the clustering approach plays prominent role here. Clustering is going to give or is going to play, the prominent role with respect to the speaker derivation accuracy. So this WLI Fuzzly clustering approach works like this. So randomly initialize the membership matrix, and you initialize the number of clusters and threshold, calculate the centroid, calculate the distance between data objects and center point, update the new membership matrix. So calculate the cluster validity index, which is nothing but WLI of C. So if it is less than the threshold, then you say that yes, it belongs to the same cluster, and you repeat this. And if it is greater than the threshold, then you are supposed to say that this particular entity or the member does not belong to this particular cluster, and you try to go for the new solution. So this in a similar way, which we have done or which we have performed there in the contribution 1, we have considered the same speakers, number of speakers, and 3 and 6. We have calculated the tracking distance and tracking accuracy. So you could observe that this has given, these are all the results plotted with respect to tracking distance, with respect to MKMFCC and TMFCC line optimization algorithm, MKMFCC and WLI fuzzy algorithm. So these are all the values. So I'll just quickly wrap up. So F measure. So here also you can find that MKMFCC and WLI fuzzy has given. See here for 120 frame length, both this MKMFCC for speaker 3 and speaker 7, it has thrown the same accuracy levels, that is 0.85 and 0.85. So this is how we got and we have calculated this FER values ratios. So here, if you look at this, comparatively good results when compared with the TMFCC and line and MKMFCC plus WLI fuzzy. So these are all the values. So derivation error rate. Here also, with respect to MKMFCC, WLI fuzzy, we got good result with respect to this speakers with 3 as well as with 6. So again, what we thought was there are certain drawbacks here with this contribution 2. Then we switched on to this contribution 3. This paper was published in Alexandria Engineering Journal. We have proposed one more feature set with respect to this clustering approach, and that is hollow entropy with extended linear prediction using autocorrelation snapshot method using deep neural network approach. So here, what is the motivation to use HXLPS, hollow entropy with extended linear prediction is, due to some low bit rates of the acoustic signal, the performance of XLPS gets degraded. To resolve this issue, we propose HXLPS. So again, so this is the objective or motivation to propose this HXLPS feature set. I mean feature extraction technique. And for clustering, we have used this deep neural network technique. So the drawback of WLI fuzzy clustering is critical to identify non-convex clusters. So see, as I said, clustering is the major role. Clustering plays major role with respect to this speaker tracking or speaker derivation. So this is the drawback. I mean, we have seen line optimization algorithm, we have seen this WLI fuzzy clustering. So the drawback here is it is critical to identify non-convex clusters. So conversation at particular point, that is very, no ambiguity still persists with respect to the two approaches with so far what we have discussed. And it is difficult. I mean, the approaches which we have seen so far, it cannot handle the huge amount of data, more data set, and at the same time, it cannot handle the data set, feature vector of more size. So, we have, if the feature vector size is say some 12, 13, 17, 18, and so on and so forth, if the size is less, okay, fine, up to some extent, this line optimization algorithm and WLI fuzzy clustering approach, it works. But if we want to go for more size, that's where these deep neural networks or deep learning concepts come over than the existing machine learning approaches. So in order to process the huge amount of data, huge amount of data means what? With respect to the size of the feature vector, with respect to the size of the data which we consider for experimentation purpose. And one more important point is, in order to in order to consider with respect to the unstructured data, we go for this. We have proposed and we have done. We have considered this deep neural network. So this deep neural network, the same thing, the pre-processing technique, extraction of features, voice activity detection, I vector representation, all are same. But here, if you look at this speaker clustering, we have done by using this deep neural network. So this deep neural network could be able to overcome the drawbacks with respect to high dimensionality, with respect to clustering approach, with respect to the labeling. If the clustering is done, obviously labeling will be easy for us. So for example, if you take 10 speakers, we have performed a maximum of say some 7 speakers. For example, if you take 60 minutes of data speech corpus, and if there are say for example 20 speakers or 27 speakers or more than 20 speakers, so clustering of their speech content is very, very important of all the speakers. If segmentation and clustering, if it is not performed perfectly, whatever that we do and whatever that we claim, it is going to be meaningless. So obviously, clustering of data relevant pertaining to each speaker is very, very important here. So far we have emphasized on 3 clustering approaches. 2, and this is the third one, line optimization and WLI, and the third one is DNN. So obviously, if clustering is done properly, then ultimately I can give labels and I'm going to get a good recognition performance. So this is how, here we have done this deep neural network, as you are pretty much aware of it. So this is the structure architecture, which looks like, it's not like, generally these days we talk about convolution neural networks and recurrent neural networks. This is a different issue, but here what we have taken was we have given input in this particular form, and we have taken some 19 features, and we have clustered into say some 7. As I said, the 7 speakers at most we have done it. So this can be extended. This work can be extended with respect to different databases, with respect to different clustering approaches, with respect to different segmentation approaches. So here we have considered two layers, layer 1 and layer 2, and we are claiming it as deep neural network. So because of these input size and because of these outputs, so by considering this network topology of this deep neural network, see what is convolutional neural network or what is recurrent neural network. Yes, you are pretty much aware of it. See, you people are undergoing this, FDP or STTP on this deep neural concept. See, it's a neural network where filters will be there. So whatever, the network itself, it contains filters. See, whatever that we are looking for, that filter will be, highlighted, and the remaining filters will be, we can say that they are closed. So the content that which we are looking for, it will be passed on to those particular filter, and accordingly that filter filters that particular information and gives the the required information which we are looking for. So in various applications are being performed with respect to image or with respect to speech or various pattern recognition tasks with respect to the database and with respect to the size of the content by using this recurrent neural network or convolutional neural network. So here in the earlier stage, I think we have done this experimentation almost 2 years back. So at that point of time, we have taken this architecture for this deep neural network for clustering purpose. So astonishingly, what we could able to find was this deep neural network with respect to this clustering has given good recognition performance for all the parameters that we have considered with respect to, say, some number of speakers, with respect to tracking distance, with respect to tracking accuracy, with respect to the F measure, with respect to precision, recall, and everything, and even for improving the frame size. By improving the frame size also, it has given good recognition performance. So finally, these are all the contributions which we have. If you can observe the ground comparison with respect to the ground truth values. See, XLPS by using deep neural network was performed in the, was done in the year 2015 by this particular author. So what we have done was, we have taken hollow entropy. See, as I said, if we can improve the energy level of the speech component, obviously we can extract much information pertaining to the speaker. So this is how we have carried out our work, and finally we have done it for, say, some 3 speakers and 5 speakers and 7 speakers. So for all the evaluation parameters, we got good result when compared with the ground truth. Ground truth means the work which was carried out in this particular area. So this is how the work was done with respect to this speaker derivation. So the performance analysis done by varying the frame length values for the speech signal. Finally, I could say that hollow entropy with extended linear prediction using auto correlation snapshot method with during deep neural network has given better accuracy. So these are all the improvements that we can suggest. The following improvements we can do here in future are: in some real-time environments, the speaker may move from one place to another. Hence, the speaker derivation system can be assigned to locate the movement of the speaker. So here, see, I am sitting at this particular place and I am giving my lecture, for almost, I'll say, some 1 hour and odd. My room temperature. See, temperature also influences the speaker recognition accuracy. Even my fan also alters the speaker recognition performance. Even the tube light which is there in my office will influence the speaker recognition performance. So always ideal environment should be there with respect to the speaker recognition. What I mean to say is, these are all the various parameters, that influences the speaker recognition performance. So what we are supposed to do is, our objective is to develop a robust speaker direction system or tracking system where it should work for all, for various conditions. So in one way of thinking is, see, when the speaker, while the speaker is moving, also he will be talking something. So how that recognition accuracy, that performance is going to vary. So we can think about that. The budding, research scholars who are planning to pursue their research in this particular domain. So the second one is the time delay between the speech signals need to be identified. So unsupervised clustering in the speakers need to be identified for better speaker direction. See, so far we have seen some supervised clustering approaches. So see, unsupervised clusters in the speakers need to be identified for better speaker direction system. See, as I said, other than these three, like say line optimization or say this WLI, and the third one is DNN, we can think about better clustering approaches where we can have good recognition performance. So these are all the publications, of course. So I hope that to some extent I could able to give the overall view of this speaker direction with respect to this machine learning and deep learning concepts. So now it is time to the participants to raise their doubts or questions. I'll be more happy if anybody can raise certain questions related to this particular concept, so that I can clarify to the possible extent which I know. So now it is over to the participants.
Yeah, first of all, thank you, sir. Thank you for accepting our invitation and delivering the session on deep learning for speech recognition, sir.
Thank you, Srinivasarao. Thank you for giving me this great opportunity.
Thank you.
Even indeed, it's my pleasure to associate with good people like you and reputed institutions like VNR Vidyan Jyoti. So look forward the same in near future, and let us work collaboratively so that we can do something good to the education system or teaching learning process.
Yeah. Thank you, sir. Thank you for your kind words. Now the dais is open. Participants, you are requested to unmute yourself and you clarify your doubts on the particular context. Sir, if possible, you send the slides, sir.
Sure.
With the participants, or if you have any other resources to work on speech recognition or speech processing.
Yeah, I'll be more happy. I'll be more happy to share my mail ID. If any of the participant, if they want to, contact me, they can ping me to my mail ID so that I will respond. And I'm ready to, help them or guide them, whatever it may be.
Okay, sir. Sure. If you have any queries regarding this particular topic, you can get queries to be clarified.
Yes, you can unmute yourself and you can raise the questions, or else you can type it in the chat window.
See, actually, it's my pleasure, and indeed, it's my duty to reveal that. I think you are pretty much aware that I am the scholar of Professor V. Kamakshi Prasad Garu, and the present director of evaluation of JNTU Kakinada. So especially for computer science students, I think majority of the participants are from computer science. I hope so. Generally we won't come across the concepts related to signal processing. So when we started our research in the year 2003, I did my MTech in JNTU Hyderabad and a PhD from JNTU Hyderabad. So while pursuing, we have come across a lot of struggles with respect to this speech concepts. So we used to visit a IIIT, we used to visit the Central University, we used to meet many people regarding this particular, knowledge. So many people have helped us, and accordingly, computer science student means what we are generally, we won't be coming across these type of signal processing concepts. Students who are having, with students with easy background, for them it is easy to cope up. So, but it's not that tough task. Only thing is you should have passion. We have good resources at Hyderabad and IIIT. Professor Narayan Garu is there. Professor Ganga Shetty Garu is there. Even Krishna Mohan from IIT Hyderabad. My guide, my guru, Professor V. Kamakshi Prasad Garu is there. So, even my scholar is from MGIT, Mr. Subramaya, who did this particular work. So, first I should say courtesy to him. Why? Because this entire work was carried out by him. So when Srinivasarao Garu approached me to speak on speech and with respect to deep neural network, then I thought this is up to some extent it is relevant to the topic. Then I thought of presenting this particular topic.
Yes, sir.
So,
thank you for acknowledging your guide, sir. Thank you so much. And we received one query from the YouTube listeners also that how can we extract features for speech processing, sir?
So that's what, madam. Speech, the major important phase in any pattern recognition task. Pattern recognition means either it may be image or either it may be speech. Now with relevant to speech, we go for generally there are two type of features where speech contains. One is system related features and another one is source related features. See, for example, if you look at the human vocal system, first if you can understand that, then it is easy to say what type of features that we can extract. You take a hollow pipe, you take one tube. In the tube, you try to blow some air. So what happens, madam? You will be getting some sound. Some sound we can get. But you try to close the other side of the tube and you have some holes on the tube. See, if you take a flute, what happens? You are blowing some air into that flute, and due to that holes, you could able to produce some sound, right? So here in this vocal tract mechanism, my vocal folds, this air pumps, this air will pump, and accordingly, this vocal tract, by interacting this vocal folds with this vocal tract, sound is being produced. So that's what internally happens. So here we can extract two type of information related to this speech. One is information related to vocal tract, or simply for example, I think you just wave your hand, madam. If you wave your hand, can you able to produce any sound? No. You just wave. You just knock your hand on the table. You just knock the hand on your table or put your hand on the table with force. You can produce some sound. So the same phenomena is applied for speech production mechanism also in our vocal tract system. So here the pressure which we apply is nothing but source. The interaction or the surface or the convolution on this source, on this system, this bench is called as system. The table, the hand which we interact, which it is going to interact on the table, for example, and the surface is called as system. The hand is nothing but source. So we see the source information is different for different people. The track and the system information is different for different people. So some of them we focus on track, that is vocal track, that is system information, and some of them we concentrate on source information. So there are various feature extraction techniques. One is Mldlt frequency substral coefficients. That is the basic one, which extracts the vocal track information, that is system information. We can think about linear predictive coding also. That is also one of the system, system related information extracting system. There are other, source information techniques like pitch, chroma. Okay, there are zero crossing rate and so on and so forth. So these are all the various feature extraction techniques which one has to concentrate in order to extract the information from the speech. So hope that I have clarified it.
Yes, sir. Thank you, sir. And one more, one of the participant is asking about data sets for speech processing, sir. Can you suggest or?
Yeah, madam. TIMIT is one of the database. TIMIT.
Okay.
And the other data set is there are. There are various data sets. Here in this particular work, we have used other data set. Even if you want to go for local languages, you can think about IIT Kharagpur database is there with respect to Telugu. Even IIT Chennai, they are developing some database with respect to local languages. So even if you approach Anil Uppala from IIIT Hyderabad, who is working in the speech processing, I think they got some project for a worth of say some 20 crores to develop this Indian database for various languages, Southern Indian languages. So there are various. This is one of the database, madam. ELSDSR, English Language Speech Database for Speech Recognition. So these are all various standard databases you can think about.
Thank you, sir.
And one more database is there, MI Massachusetts Institute of MSIT, some other, MIT database is also there. You can think about that also.
Okay, sir. Thank you. And one more, sir. Is there any scope in instrumentation engineering in process industries like thermal power plant, steel power plant? Any scope is there, sir, in instrumentation engineering?
Can you repeat it, madam?
Is there any scope in instrumentation engineering is there, sir, for this speech processing, like industries like thermal power plant, steel plant? Any scope in instrumentation engineering?
With respect to, these days we are talking about artificial intelligence. These days we are talking about robots, right? So wherever human intervention is not required, wherever we want to automate it with respect to speech, we can use this particular area, madam. Hope that you got my point.
Yes, sir.
See, suppose if I want to give instruction orally instead of giving manually, or instead of say if I want to do, if I want to convert from speech to text, or if I want to convert from text to speech, or wherever human intervention is not required, these speech applications can be intruded into that.
Thank you, sir. Any queries from the participant side? And we received a good feedback from Sweta Suresh that your information shared by you was very clear with setting path for research, and they are wishing to have some more detailed lectures from you, sir. Thank you.
Yeah, it's my pleasure, madam. Thank you.
Yeah, so it's also our pleasure to have you, Dr. Rajesh Rose, sir, to this STTP. Thank you so much. Thank you for sharing your insightful knowledge with us. Your session was cheerful session. Thank you once again, sir.
Thank you, madam. Thank you.
Thank you, sir. Thank you very much.
Thank you, Srinivasarao Garu and Revati madam and other other organizers, coordinators, head of the department, principal and management of ENR Jyoti for giving me this great opportunity on this great day, great occasion. Thank you. Thank you very much.
Thank you, sir.
Thank you.
Dear participants, now we'll take break for lunch. That's the end of session on speech processing. Afternoon, we'll start the session at 2 o'clock. Afternoon session is on plant disease identification using convolutional neural networks. It's the practical session by Dr. Jagan Mohan Reddy from Mylavaram. We'll share attendance and feedback link in Google Meet and YouTube. I request all the participants to fill the form. welcome back. Good afternoon to all the participants. We'll start the session. Uh, Now we have the session on plant disease identification using convolutional neural networks. This practical session will be delivered by Dr. Jagan Mohan Reddy sir from Mylavaram. We welcome you to this AICTE online sponsored STTP on machine learning and deep learning techniques, sir. Good afternoon. Welcome you, sir. Jagan Mohan, sir.
Thank you, madam.
Before hand over the session to Jagan Mohan Reddy, sir, I would like to introduce him. Dr. Jagan Mohan Reddy garu received PhD from BITS Pilani and his master's from Jadavpur University and BTech from JNTU Hyderabad in CSC. Dr. Reddy served as a data analyst and full stack developer at Vedavog Systems Limited, Hyderabad, and he also worked as data scientist at Kotri Software Solution Private Limited. And Dr. Reddy currently associated with the Lakkireddy Balareddy College of Engineering, Mylavaram, as associate professor. In addition to that, Dr. Jagan Mohan Reddy developed various commercial and academic projects available in GitHub. Dr. Reddy has published research papers in various peer-reviewed conference and journals such as Elsevier, Springer, ACM, and IEEE. Dr. Reddy is a member of ACM, IEEE,
ఇది ఆన్ చేయన్న నాది
of
వాళ్ళ వాయిస్
International.
రావట్లేదు.
Sir, okay. So, Dr. Reddy is a member of ACM, IEEE, life member of International Association of Engineers, and member of IUCEE. So, I would like to invite you to this session, sir. Jagan Mohan Reddy, sir. Hello. Sir, is there any problem at your side? Dear participants, please wait for a few minutes. Sir will join the session and he will take over the session. Uh, Good afternoon, Jagan Mohan Reddy, sir. Are you there?
చూడండి వచ్చింది. Yes sir. Okay sir.
Sir, you can take over the session.
Thank you ma'am. Sorry for the disturbance. So there is a small glitches in the internet side. First of all, good afternoon to all the faculty members and if students are there. Thank you for introducing me the brief introduction about me, and I am very fortunate to be part of this STTP program. So today I'll be covering on convolutional neural networks. So which is a part of the deep learning. Okay, ma'am, can I have a presenter option?
Yeah, Dr. Jagan sir, you can present.
Okay, yeah. Okay, thank you ma'am. Is my screen is visible?
Yes, visible.
Okay. Yeah, I didn't prepare the much of the slides regarding the convolutional neural networks. As is asked me to present directly the coding part. What I do is I'll be talking about the 3 to 4 different convolutional models that are present. I hope a couple of them you can get it from the over internet. What is the architecture and how it is designed? Okay, I'll be talking about the first one is the very well known, or I can say that the second version of the deep learning model, that is VGG 16 model. Okay, so this is developed by University of Stanford. They have developed the second version of the, or in fact we can say that they will large image net, the first convolutional operations on an image net. So prior to this we have a LENet. So LENet 5 is one of the famous, but nobody understood that it is actually performing the deep learning aspects. Okay, so in the beginning of the deep learning evolution, they started off with the, okay, it is only the LENet 5, where it has a 5 different stages in the deep learning model. Okay, so when it comes to VGG, so they built with a image net, almost like a billions of images they have constructed in their approach. Okay, so the model built based on the first convolution operation. So first it has a convolution operation, and they perform the second convolution, and then they perform the pooling operation. So what do you mean by this convolution actually means? So it is something like this. So the convolution operations are in the form of, for example, given a grid. So this is an image, and this entire image, they are divided into blocks. Okay, they are divided this entire image into blocks like this, and they have selected the small chunk of images, small portion of the images. I can say that a kernels or maybe filtering approach. So there are various names are associated in the image processing segment. So one such approach is that divide the entire image into as a matrix form, and you perform the filtering approach or kernels as a small n by n matrix that is going to be run through this an M by N image. So in the initially the image cannot be the same size, cannot be an N by N image. So it can be an N by M images, okay? And the convolution operation is performed is based on the an N by N image. So what is this convolution operations generally? So in the beginning study of operation of the image processing, the filters are heavily used for the edge detection purpose. So given any image, and we are in a position to extract the boundaries of any image. Okay. For example, here I'll show you one image. The edge detection and the any other image boundaries are extracted by the deep learning, the CNN models. In early case, first what we do is, given this image, we need to first identify what are these edges. And the edges can be vertical and horizontal, and these convolutions can be applied. First, initially we will select one convolution as a 5x5 matrix, and that is going to be applied for the entire image iteratively. Here I'm just putting the example purpose that how these images can be divided into an N by N matrix. For example, if you apply one filter algorithm or maybe convolution operation as a 5x5 matrix, so the first 5x5 matrix, we are going to define a standard matrix as an edge detection matrix. Take this pixel value, the original image pixel values, and with the filter image multiply, and then take a sum of all of them, these values. You'll be having all those run through the 5x5 matrix horizontally. So similarly, you do for a vertically to detect the edges of this particular image. And we have the diagonal also filters we have, so that the diagonal filters also can be recognized, and reverse diagonal features also can be extracted, and so forth. Likewise, there are various features are going to be extracted automatically using convolution models. But before the evolution of convolution, we have to choose our own set of edge detection methods where they are going to give the different patterns, and all of them we need to merge together to extract the features. That is going to be completely avoided by the convolution models. And the other advantage with the convolution operations is that we can directly work with the color images. So before evolution of the CNN, we have only alternative is that we have either you have to work with the binary images or grayscale images. So once you start with a binary image or a grayscale image, we are losing some of the intensity value of in images. For example, in this particular location, there is a high intensity because of dark green it is. So if you convert this into a grayscale image, let me convert this into a grayscale image and see that what is the impact on this image. Now look at that. So somehow the color intensity is going to reduce here once you convert them into grayscale images. But we are losing the sensitive information here in this particular image. So that's why there is a disadvantage with the earlier version of the image processing techniques. So that is another advantage with the convolution operations, it is giving you provision to work directly with the color images. So where we call it as the RGB channels. Okay, each and every channel has a different properties extracted from an image. So that is the one greatest advantage with the convolution operations. To be more clear, so how are these images? The features are extracted in a VGG 16 and VGG 19. So they developed two different model, 16 and 19. So why they have given a 16 and 19 is their operations. They have a 16 stages to flatten the images. Okay, so first they are applying two convolution operation, then they are going to be applying a pooling operation. So I hope the names are very familiar, because the pooling is nothing but we are going to select a subset of matrix from the convolution operation. So how it can be explained is, for example, this is the image I have. So in this image, so I'm assuming that this is one of the grid that I have applied the filters. Now what is the pooling operation is that, so the pooling generally is going to be a 2 by 2 matrix, and we have a three different pooling operations that we have. One is the max pooling, and we have a min pooling, and we have a average pooling. So what are these actually pooling is that, for example, if the 2 by 2 matrix, if you're placing in this particular position, so if you're choosing maximum pooling of this 2 by 2 matrix, one of maximum element is going to be selected as a subset of matrix. So we are going to reduce the dimensionality of the feature space of the image. That is another advantage with the convolutional neural networks. The one advantage is that the feature extraction can be automatically done by CNN, and other one is the dimensionality reduction is inbuilt in the CNN models. So if I'm assuming that the max pool, if you apply after convolution, that means the whole image out of these four values, it is going to represent one value of this entire grid. So what is the highest value indicating in this entire 2 by 2 matrix is it is going to be the highest intensity value of this particular small grid. So similarly, I will again iterate the another 2 by 2 and then another 2 by 2. So we are leaving every 2 by 2 matrix, and among these, one of the maximum value we are going to fill in the next level matrix. If you say that it is a min pooling, that means minimum values among this particular grid is going to be chosen as a next level of convolution operation. If you talk about the average in this entire 2 by 2 matrix, take the average value and then put it here. But while the construction of the reconstruction of the image cannot be obtained on this average, because you may be having an equally distributed, but in the original image it may not be equally distributed, the values. So it is suggested that from the literature, the researchers suggested that generally you go for a max pooling concept to be able to represent the one intensity highest value or intensity pixel in this particular grid. Okay, so that is how the dimensions are going to be reduced in the convolution operation. For example, if you have a 32 by 32 image, okay, 32 by 32, and if I apply my kernel size is going to be 5 by 5, and the convolution after the convolution operation, your image size is going to be reduced by a 28 by 28 image. Look at that, 32 into 32. Look at that, the dimensionality of the image has to be reduced in the second level is going to be 28 by 28 after applying the convolution operation. And then if you apply the max pooling, then this becomes another 14 by 14. So likewise, the dimension is also parallelly reducing in the convolution operations. Okay, so that is what the advantage of the convolution operations. So look at that. This is one of the convolution model as AlexNet. So I'll be demonstrating how the AlexNet is constructed, how we can construct this, the flow from starting in image to the flattening of the images till the fully connected network. So in the beginning, they started out with you take any image of a size, it has to be scaled down to 227 by 227 into 3, this 3 indicating the RGB colors. Okay, RGB color. And in every band, the convolution operations are applied here. It is not for all the bands in a single go, but 3 different convolution operations are applied, which are 11 by 11. So the kernel size is going to be here, the 11 by 11, and total number of filters are going to be, the stride is going to be 4. Every time they are going to leaving out the 4 cells, because they have to cover these 227 by 227 filter. So somehow they come up with this example 11 by 11, and the stride is going to be 4. So once they applied the convolution operation, then the max pool size, as I mentioned, that 2 by 2 matrix, or in the case of AlexNet, they have implemented the 3 by 3 matrix. And then they have repeated the same to reduce the matrix is into another form. Likewise, it is going to be, look at that. So these are the number of parameters in the beginning that we have. So in the end, it is going to become a flattening of all the portion of images is become a 9046. So the entire fully connected, they are bringing down from a 227 by 227 by 3 are the actual parameters that we need to work with, or the number of features that are associated with a single image, that is going to be bringing down to 4096. So how are these 4096? What is really indicating this 4096 is these are the actual intensity values of the of this particular color image. So that is the whole idea about the convolution neural network. We need to reduce the dimensionality, and we need to extract the features automatically in a single structure. But as in early before evolution of the deep learning concept, these are the different subsets. First, the edges are detected, and then features are extracted. Probably we may use the run length encoding mechanism to extract the weights or features of an image, and then we are going to be separated, construct the neural networks, artificial neural networks, to be classify the images. So all these 3 are integrated into a single image as the convolution neural networks. Okay. If it is 2D images, so if the image, if you are working with an image, then you have to use this structure. But what about the text data? So can I apply the text data to CNN models? Is the CNN model, you may be having a doubt that, can I able to apply the convolution neural networks for a text data also? Yes, it is, but that is 1D data. You can also apply the convolution neural networks for the text processing also, but that is 1D. The structure is different. This is specially designed, these kind of models are designed especially for 2D images. Okay, 2D and 3D images. So beyond that, we cannot process as of now. The literature is available only for the 2D and 3D images. Okay, so this example is for the BGG19, where it has a 19 operations are performed in the structure. Okay, So here there are 19. So this is 16, and these are the 19 steps are involved from the input to the softmax. Softmax, after the fully connected layer, we are going to perform the artificial neural network node. So these are the wide variety of approaches are available in the convolutional neural network. You can design on your own neural network also. You can design on your own convolutional neural network where you don't need to follow this, but you need to ensure the level of connectivity from one stage to the other stage. Look at that. The first convolution operation here they have applied on an input image, and it has become a 64 the size of the image. Okay, now the 264s will become 128 to the next cell. So you need to make sure the number of features from the previous to the next level. And here you have performed the 128 and 128. Now here it is going to be a 256. So slowly it is going to be flatten up to 4096. So here they have performed 512 operations, okay, and then they reduce up to 4096, the dimension array. So likewise, there is a connectivity in between the one layer to the other layer. So if you miss this, convolution layer may fail in the construction of the uh, outcome of your model. Okay, so we need to ensure the one stage to the other stage, the number of features you need to represent it appropriately to the up to flattening the network. So these are simple three different kind of CNNs. I'll start with the how do we implement this VGGNet if the data set is ready-made available with you. Okay, so ImageNet already built by so VGG in 19 and 16 already model is available for a ImageNet. But what if I have my own data set? How do I fit the VGG model and AlexNet? Okay. So here the today's agenda we are talking about the plant relay the plant disease detection. Okay. So so I hope you might have heard about the Plantix app, which is very popular in recent. But if you take a photograph of any of those plants, be a corn or be a mixed chili or be a mango tree or any of the agricultural product that we have, if you simply take a picture and upload to the server, and it is going to return saying that what kind of diseases that currently the tree has, and it is also recommending what are the pesticides and per liter how much water you have to mix with. All those details are provided by Plantix app. So the background of this entire Plantix app is that the deep learning, the convolutional neural network, and they trained over almost a million images collected over a period of time. Okay, so one such data set that is available with me is that plant village data. Even if you Google it, you will get the plant village data. So currently you get only for these kind of categories. So they have potato, spinach, tomato. They have almost 10 varieties, and strawberry, apple, blueberry. So in this also they have a variety of diseases they are tracked, and each and every portion of the image they have almost 500 to 1000 images they have collected. It is varying from one plant to the other plant. So minimum 500 to 1000 images they have collected from each and every plant. Okay, in case of tomato, they have almost 1700 wide variety of bacteria are collected. A lot of background work done by the plant app people that they come up and saying that accurately say that the disease classification, okay, which is available public domain, and they also have the train and validation data also for the same class. But one suggestion from me that do not run on your local PCs, because it requires a lot of RAM to run these billion images. Okay, these million images cannot run by a normal CPU. It has to be as in a bigger server, or even it is even suggested use a GPUs. So that is a one advantage for today's purpose. So what I have done is, so tomato is one classification I have taken. Under that, there are around 6 disease classifications that I have considered. So it has the tomato healthy leaves also affected by the plant village blob or plant village. Okay, you can easily obtain the healthy tomato plants. Okay, the disease classes are defined here. So I do quickly that. So here I have notebooks, 2 notebooks I have created for the uh, both VGG 1619 as well as the AlexNet. Uh, the background is required for the plant disease detection or any convolution operation on a 2D images. Either you learn the Keras is one of the TensorFlow library, or you try the PyTorch. And recently there is a Facebook model called Cafe 2. So we have 3 different libraries currently available on deep learning framework. So what are those is, so one is the Keras, and PyTorch is another library, or you can try Cafe 2. Okay, Cafe 2. This is the, so these two are from Facebook. PyTorch and Cafe 2 is from Facebook. Keras is from other company. They have built it based on the TensorFlow only. Okay. So these are popular libraries currently. You can implement all the deep learning models using these libraries. Okay. So in today's example, I have considered the Keras models. Okay. So here I'm importing the necessary libraries. What are the necessary libraries that are required to do convolution operations on an images where it has the convolution operations, because we are mentioning is a convolution 2D. Okay, 2D operations. Maxpool is also 2D. Okay, and so the label binarization is done by a scikit-learn. Okay, and so here we have activation functions, and we have a flattening the images, uh, and so here we have a pre-processing images, and what are the optimization techniques that you can use uh, in the convolution models. Okay, so all those libraries I have imported here. So these are the parameters are required for VGG. These are the parameters. Or we say that, so there is a difference between, so in one of the interview, they asked me that, so what is the difference between the parameters and the hyperparameters? Okay. So these are the hyperparameters. So that means the number of inputs that we are giving to the algorithm is externally we are providing. So internal parameters are that the size of the images are going to be used for the algorithm. So anything that you are externally supplying, for example, batching, for example, every time how many number of images we need to process, and what is the default size of the images, Okay, and what is the depth of the image? That means whether you are giving a color image or maybe a grayscale image. So these are the hyperparameters that we need to fix for any algorithm. And in the parameter, the size of the images and how many convolution operations that you are doing, all those actually the parameters of the convolution operations. But here I am giving the very small number of iterations because even for a 100 images, it is almost taking half an hour to run in my laptop. So though it is an 8 GB machine, so that's why I'm reducing the number of iterations to process. So for our study purpose, so I have considered the 100 uh, different type of images for different classes. Okay, so total 600 samples that I am using for the today's lecture. That's why I'm putting the very small number. Even for 100 images also, it is taking a lot of time for a number of iterations. And I am setting the 128 by 128 size for VGG because the VGG is developed for the size of the image is 128 by 128 only. But whereas AlexNet is defined, they have mentioned the image size is 227 by 227. So these are predefined width and height of your images to be an n by n image. Okay, even if it is not an n by n, the internal operations of the library, it is going to automatically resize the images. Okay, the convolution operations, the Keras library internally, it has a normalization where it is going to be scale the image whatever the image size that you have given. Okay, so here I am converting the images into an array form. All the images, whatever the images I have within a directory, I'm just putting them in an order. Okay, so here what I do in this here is I am going to collect the image list as well as the labels. What are the labels that I have?
Again, sir.
Yes,
Please increase the size of the screen. The text
screen
font
is not visible.
It is visible. Increase the size of the font or zoom it
Okay,
to
okay,
see the code. Yeah, yeah.
sure.
Participants are asking to see the code.
Is
Yeah.
it good enough?
Yeah. Proceed.
Okay, thank you. I'll do even. I think this looks better. Okay. So these are the necessary libraries that I have imported. These are available from the Keras library, and you may ask that so many libraries that we have to import because we can directly use the Keras.layers and all these uh, libraries automatically can be exported directly. Okay, can be imported directly. We are mentioning specifically that why the normalization layer what it has. Okay, it is specifying that it is coming from a batch normalization, and we have another class is given within the Keras is convolution 2D, and internally it has a convolution operation purpose, and max pooling 2D is also available in the convolution layers. So we are detailed written here that what are the specific definitions are can be used in from the Keras library. So Keras is a library, and internally it has a one class, and then it has a definition. So that's what it is. How the arrangement of the Python libraries. Okay. So this is a class. Internally class we have a different libraries, different definitions are created for every function. So these are the once I imported. So these are the hyperparameters are going to be designed for every algorithm. Okay, so still now I didn't start the actual VGG model. I'm just importing the data set. I'm just setting up the what is the input size of image. So here the width and height of the image is 128 by 128, and I'm mentioning the depth means whether you are giving the input as a color image or a grayscale image. It works even a grayscale image, you put the depth as a 1. Okay, if you are working with a grayscale images. Okay, So that is the second part. So what is this? BS is the batch size. Every time how many number of images the algorithm supposed to be iterate. So given 1,000 images cannot be processed due to the memory overhead. So that's why the Keras library internally develop every 32, whatever the size that you have mentioned, generally it is powers of 2, and then it is going to be iterate those many images and then collect the overall output. And this is going to be the convert image to array. I'm just simply keeping them in as a list, all the images and the uh, image names and then the extensions. Okay. And so this is the function where I'm going to collect the class labels and how many number of images per class. So that list is going to be maintained here. So where image list has the all the list of images and what are the associated labels. So how this can be visualized is that this function is going to be something like this. So the function works in a, so I think probably we may be having an idea that, so here this is going to be feature 1 up to feature n here. Okay, and these are the image 1, img1, and the label is stored in the labels L1, probably L1, L2, L2, and so on. So the definition that is written here is the in this form: image list and the label list separately with the whatever the order that you are visiting in a specific directory. Okay. So here I'll first obtain the root directory. Within the root directory, how many number of folders that it has. So here I have 6 folders are available. All those 6 folders, again I am going to internally iterate how many number of images that are associated. So here you can specify the number of images that you want to process. Currently I have 100 images in every folder, so you can limit this. Instead of 100 you may be mention the 50 also, but we cannot achieve the good accuracy. Okay, so we have 100 images we are limiting, and if the extension is going to be .jpg, small jpg, or capital jpg. So the currently the plant village dataset extension is .capital jpg. Even if it is smaller to smaller uppercase, then we can able to process it. So this is simply the data arrangement in a memory. Okay, all the images are gathered here. I'm just looking at the size. So I have total 600 image list I have. From the six different classes, each and every folder I have a 6 different 100 different images that are associated in my directory. Okay, so that is how, look at that. In early case we have to write it our own everything. The Python is make it easy for us to gather the class label as well as the image labels, everything in a single piece of code. We can able to obtain the image labels as well as the image names, and then we are going to be label the binarization. So here the names are given in a text format. Python does not allow the classification. What you do is you convert them into, you encode them into zeros and ones. So probably you may be having a doubt that how I am able to say that is this going to be labeled as a 0 or this is going to be labeled as a 1. Okay, the indices how it is going to be generally given. So it is purely based on the alphabetical order. Okay, so purely based on the alphabetical order, it is going to be label your binarization. Okay, so once I am going to binarize the label, I'm going to return the number of classes. Okay, so these are my list of class labels which are the binarization happened, and in that we are going to store the labels into the labels underscore transform.pickle. We are going to store them into a pickle format as a serializable object. So we are going to normalize the image because if we cannot be normalize the images, the intensity values are maybe we have a too high or too low. The intensity values are too high or too low when we are working with. That's why we are always suggested that the intensity, the value is supposed to be normalized for 255 values. So you may be having a doubt that why it is only 225 range, or why can't it is 256 or maybe some other value. By looking at the maximum values that are coming from in your data, then take the maximum value and then normalize all your data, or you can predefine whatever the value you want. Okay, or probably you can do with the 128 also. Okay, it cannot be a 225. Okay, so this is the, and then once you normalize it, your images, then we are going to create a train test and validation values. The validation values are going to be separated as a train test values. Okay, to just to see the performance of my data set. So here I mentioned my test data set is going to be 20% of the, that means 200 samples are going to be used as a test and 400 are going to be used as a training only. So in a single step, I'm able to extract the train and test values. Okay.
Excuse me, Dr.
Yes,
Jagan
please.
Mohan sir. Yeah, there is a lot of noise near your surroundings, sir. Some disturbances we are so unable to concentrate.
Okay.
Yeah.
Sure, ma'am. I'll make sure that it will not come. Okay.
Thank you, sir.
So once the scaling is done, then what we need to do is so once this normalization of an images of my all the training images, then we are going to create the augmentation, that is image generator. So what is this image generator does is we are going to perform the scaling and rotation. Okay, so within the image generation we are going to identify the scaling of the event, because I'll simply explain with an image why we do the image transformations here. For example, this leaf that is currently available, okay, and I have clicked in this direction. Someone may click in the in slightly going to moving a direction in a 45-degree angle, or maybe 128-degree angle. So what happens if the rotation is going to be changing? Then it is a problem in the detection part, right? So the currently this is the exactly 90-degree position of the particular image. What happens if it is slightly in 40-degree angle, or maybe in a minus 45-degree angle, or maybe 60-degree angle? So to even consider the scaling and then rotation also, this image, so this augmentation does for it, and it accurately identify the nearest neighborhood in the rotation, and then scaling is adjusted in the image data generator. So the name itself is image data generator, is it automatically generate even with the angles of an image. So I hope this is clear, the augmentation of the data, because in one angle if you click the picture, but if you change the angle of the taking of picture and give it to the system, it may fail. So it has been studied over a couple of images, and then they come up with, say, this image data generator is created. Okay, so once this image data generator created, it automatically learns even if you give the other angle of images. Okay. And then I am going to import the Keras. The greatest advantage with the Keras is the VG16 model is inbuilt in the Keras model. So otherwise, what you need to do is we have to construct the Keras model on our own. So whatever the model that is provided here, this model we need to construct it within the a Keras model, or maybe even a Python or any other convolution library within the Python. First, you need to implement the convolution, then second convolution, then max pooling. So as of now, we are not doing that. Once you import the VGG16, the model is ready for us. You can ready-made use that model default. That is what here it is. I'm going to load the necessary libraries related to the VGG model, and then I am using the VGG16 model here. So the input shape of the VGG16 is 128 by 128 by 3 is the depth of the image. It is a color image or a grayscale image. So once this is done, we are going to define the average pooling rate, how you want to construct the final layer of your one layer to the transforming to the other layer, what is the dense of your layer, what is the activation function you want to use it. Those details are need to be mentioned for any model, not for the just VG16. So only these 3 steps we need to create. Remaining up to here, which is available by default, only thing is we have to flatten the network. For a flattening of the network, only we are writing these 4 lines of code. Okay. So this is if you want to freeze the number of layers, that means I don't want to create the more number of layers. Create. This is not a mandatory step here, but till here we need to do on our own data set. If you have your own data set, how VGG16 can be fit into your data. And here we have we need to compile what is the algorithm that you want to use to find out the optimum weight to accurately classify the specific labels. I hope what do you mean by that optimization, and then what do you mean by weights of a particular image. If you think of in a linear regression fashion, logistic regression fashion, there is a straight line we are going to create, and then the weights are calculated based on the least square model. So all those things are common, but there is a ADAM is one algorithm effectively implemented for the CNN, where it is going to be, what it does is it is going to implement a binary cross entropy. I hope most of them are having an idea of the entropy, cross entropy. So why they have mentioned is binary cross entropy is going to consider at a time only 2 different classes to produce the output of a algorithm. Okay, so this is going to be optimization. What optimization technique you want? So Adam is the one algorithm which is effectively implemented for CNN. That optimization internally it has a gradient descent. Okay, the gradient descent is going to be used in Adam, where it quickly identify the solution of any given 2D plane weights to be able to linearly separate 2 different classes. So that is going to be the optimizer it is required, and you can give the model.summary. It is going to return how the model of your VGG16. Now see that in the first layer, input layer, so the first one we are keeping none. We do not supply any parameter here. So the input is going to be 128 by 128 and 3. Initially the parameters are 0. And then in the second stage, it is going to be 128 by 64 here. It becomes the 3 channels become a 64 channels, and number of parameters are 1789. So likewise, So whenever you do the max pooling, there are no parameters here. Only the parameters are calculated for a convolution operations only. Now we started up with a 128 by 128 by 3, and we end up with a somewhere around 3078. So this is going to be flatten the entire data into only 3000 features only. So where is this 128 by 128 by 3? So all are multiply 128 into 128 into 3. Those many features we have for every image, that is going to be reduced into the 3780. So you may ask that why only 3078? Can't be this 4000 or can be this 1000 also? Yes, it can be, but we need to see the accuracy implementations. Okay, so total number of parameters that VGG is going to be optimized, need to be optimized. The gradient descent is this, and these are the training parameters. Okay, and this history is going to be actually fitting the model. So what it requires is, the fitting model is that the input of the training data and the training label, and what is the batch size that we mentioned. So every time in every flow, the 32 images are going to be tested as a train and validated as a the remaining whatever the number of images are left out. Okay, so every time the 32 images are going to be trained in this, and those are tested against the test data. So this is actually the history is going to be created, or where the model is going to be fit on your the training data set. So I just given a 2 iterations, let it complete, and we can easily plot the accuracy on the training as well as the testing data. If I give the epoch size, if it is like 20, 30, or sometimes it is been observed that if the epoch sizes are keep increasing, then the accuracy also may increase, but it is not always. The size of the epoch need to be chosen carefully, so the system may not hang, or it cannot be run out of memory on your small PCs also. If it is a server with a capacity of 128 GB and with more CPU cores, then you can run the number of epochs like maybe 50 or maybe 100 also, but it will take definitely days. That's why whenever you are working with a big data sets, it is better to run the code in the GPU itself, because GPUs are very fast. So at every stage, it is going to return the what is the loss and what is the expected accuracy. So in a single iteration, the accuracy maybe keep changing, because the algorithm is keep learning on its own with the given hyperparameters. So once the train is done, I'll show you the testing also with a test image data can be supplied, and then see what class it is going to be predicted. There are many plants need to be incorporated in the plant disease category. Currently, there are manually working on the disease classification done by the Plantix app. If you want, you can contribute to that, or maybe we can develop our own model. But generally, they are hosted in the cloud-based application, because they are enough storage capacity and then computation speed. So generally, these models are hosted in the AWS or Azure platforms. So then you will implement an Android application, and then take a picture, send it to the server, and obtain the results and then show what you want to show, that what type of disease that is currently it has. So one such project that you can think of that in local market are the desi flowers classification, we can able to do it. So I hope that is not yet done in the literature as of my knowledge. So we have a various flowers are available in our India, that you can think of that collect the high quality images of the various flowers, and then see how do we able to classify them. And even if you want to do the disease classification for the any specific flower or maybe any other specific crop, yes, you can able to produce with this set of small introduction. I think it's minimum running the 5 year, which is history here. So the same thing can be let it be done. It's taking another 5 minutes definitely. VG19 is also same. The only thing is you just simply import the VG19 16. The rest of the part is same. There is no change at all. Okay. But whereas when it comes to AlexNet, so what I've done for AlexNet is I have created the layer configuration in the AlexNet. So till now here it is the same. The number of libraries are same, but when it comes to the hyperparameters are different in case of AlexNet. And the default size of the image is almost can be changed from 256 to 256, and the resized image is going to be 224 by 224. Okay, so this is the input size or input image size. The default is 224 by 224, and the rest of the things are same. Here we are collecting the images and the number of images in the same list. Okay, so till here, up to image generation is also same. The only thing is now, so these models are a sequential models, because a step-by-step process it is going to implement it. That's why, so there is a sequential method is loaded as a class, as a model, and we need to add every layer to the sequential model as a whole pack, as a package. If you want to run this algorithm, then we need to put all of them in a single model. So that's why the first convolution operation, so how many number of filters you want to implement, and the input size of the image here, and the kernel size is 11 by 11, and the stride is like how many number of columns you want to skip and then apply the filter. That is what it is, the stride operation. And padding, if the image size is not fitting to with this kernel size, then we have a padding is going to be added. That means extra zeros are added. There is no loss of information to just make the size as image size as a n by n only. If it is fitting 224 by 225, it is well and good. What if the image size is not 224 by 224? You simply add the zeros to make it the image as a n by n matrix, and then activation function is going to be ReLU, and the batch normalization is applied, and the max pooling. So this is the first convolution layer operation of the AlexNet. So what we discussed in the beginning, how the AlexNet can be seen. So here the image size and the filter size is going to be 11 by 11, and skip the number of columns and then apply 11 by 11. So if you apply like this, you can cover the this 224 by 224 7 image. That's why it is going to be 224 224, and the kernel size is going to be 11 by 11. You may be asking that who is giving this kernel size or kernel values. As I mentioned that there is a overlapping on image, and we are going to run this 11 by 11 image on this 224 by 224 image. How I am going to obtain this 11 by 11 image values? So these are randomly drawn from your image itself. So these are randomly drawn from the image itself. So the 11 by 11 is picked from the within this image of type. Total 96 of those such types are randomly generated. Okay, that is another greatest. Nobody is going to supply. So in early versions of the image processing, edge detection is that there are sober filter. There are certain filters are designed to detect the horizontal edges and vertical edges and diagonal edges. But these filters are automatically selected from the image itself, in the input image itself. Okay, nobody is going to supply externally. Everything is chosen randomly from the image itself. As 11 by 11 filter is created from the image itself. So once this is done, the first convolution, then the max pooling is done, and we have a convolution layer 2. So the convolution layer 2, we have a 256 images here. So this is going to become a 256, and the kernel size is going to be reduced from a 11 by 11 to a 5 by 5, and we have only skipping the only one column. Okay, so that is going to be form the second layer. And the third convolution layer, we have a number of filters are going to look at. There is a connectivity between the number of filters and the input size here, the kernel size. As the number of filters are increasing, the number of parameters are going to be reduced. Your input type of image is going to be reduced. So the kernel actually means that the weights are extracted from every layer. What are those weights? Are nothing but the high intensity values of a particular layer is going to be stored as a filters. And then likewise, I am going to construct the convolution layers, and in the end we have the total input shape is going to be 224 into 224 into 3 is the image, can be flattened to 4096. Okay, so here this is the 4096, and then we are going to stop the flattening of the layer. So in the end they are going to be again reduce that into 1000 images, 1000 features. As a fully connected layer will become for a softmax, it is going to be 1000 nodes, 1000 neural network nodes are going to be created here, and then the activation function is going to be generated. So this is, if you want to develop on your own the convolution operations, you prior calculate manually what is your input size and how many filters that you are applying, and what is your kernel size, and what is the stride size of, I mean, how many number of columns you want to skip. You have to practice it before creating on your own model. Okay, so you cannot randomly put that my image size is going to be 128 by 128 and the filters are going to be 4 and the kernel size is going to be somewhere like 64 by 64 and the stride is going to be 1 by 1. It cannot be like that. We have to practice this first on your own, and then you have to come up and saying that okay, this is my architecture, and then you put in the form of then it is run properly. So one thing that I have shown here is that how to use the existing model, and the other one is that if you want to create on your own the deep learning or a convolution layer, implement using the Keras library. The same procedure even in PyTorch, the same procedure even in the Cafe2 library also. The only thing is, here it is mentioned Mldlt, maybe something else, model dot maybe append or some other way of adding the layers to the in the sequential mode. That is the only difference. So this is how we can create our own models. So the Alex model is already, I think, it's also running, training the network. So this also has to run. Run with the one walk. Then run very fast. So model summary I have ready here, and optimization function and the history. So just see that the only the 5 times running of this, it is taking a lot of time. That's why it is not advised to run the deep learning models with a huge data on a personal PCs. It's better to run it in server versions. So if you have any doubts, I can clarify. It is taking time.
Is it over, sir? Yeah. Okay.
So I'll share both the notebooks to Srinivas sir. He will share the code, and you can run it on your own manually. Make sure that the folder structure be what I have mentioned. That we have one top layer. So the
Okay.
folder structure must be made another run. Okay.
Okay.
So that's why he has written a collection of images. So in a one folder, so you have a classification here given a tomato, and inside you have all the subclasses. Okay, that's how it is going to be collect automatically the labels of the different plant diseases automatically from the folder itself. No need to write it manually the of the labels. This is the folder structure you need to maintain. Yes, sir.
Okay. Over, sir.
Yes, sir. Yes, sir.
Yeah. Thank you. Thank you for accepting our invitation and giving the practical session on the deep learning usage in plant disease identification. If possible, share the data set, and some people are also asking for the code. Please share the data set and
Yeah, sure.
yeah, so that it will help the participants.
Data is almost like a
Plant
4
village.
GB or something. I'll definitely share somehow. I'll share the data set also, the whole data set, whatever it is available.
It is available in the, I think, GitHub, no?
In Kaggle and GitHub, it is available, sir.
Plant
Directly
village.
if you just plant village data set. If you type, or maybe you can search like the plant disease identification data set.
Yeah, yeah.
If possible, share the zip file.
And it is
Yes, sir.
having, I think, 20 crops is having 4 to 5,000 images. Almost,
Yes, sir.
yeah, nearly 1 lakh images will be there.
Yes.
You
Yeah,
select
almost.
only one or some sample, at least 5 to 6,000 images. Anyhow, it is
Yeah.
available open. It is available to all.
In Kaggle, yeah. So it is almost the size of
Anytime,
this.
please unmute yourself and you can clarify your doubts with the speaker.
Excuse me, sir.
Yes.
I am Srihari.
Yeah.
Yeah, sometimes I'm
Please.
getting module not found. What is that mean, sir? Sometimes I'm getting and sometimes I'm not getting. Then how can you fix those issues?
So those issues generally deals with the changing from one version to the other version. As of my knowledge, if the
Okay.
module is not defined, so what happens is that we have a different ways of implementing this deep learning models. Sometimes they may directly work with the TensorFlow model itself. So someone may work with the TensorFlow with Keras combination. Someone may implement only the Keras models. So there is a library differences. The code may be given somewhere which may not be available installed in your PC. That is the only thing. Otherwise, there is no problem with the model.
So if I am not installed that one, how can I install? So using command prompt only.
Yes, sir.
PIP,
PIP model.
PIP.
Yes.
Yeah. PIP
Yes,
only.
sir.
So, but I
Yes, sir.
already installed, but it is working using Python IDE. But
Okay.
it is throwing
Which
an error.
IDE you are using, sir? Which IDE you are using?
Sorry, IDE 3.8,
Which
sir.
IDE? No, sir. No, sir. Are you
Python,
using
Python,
any IDE
Python IDE
in the
only.
Python?
Command
IDLE?
Yeah,
spider.
Is it
IDLE.
IDLE you are using?
Yes,
Okay.
IDLE only.
Okay. What I do, I suggest you that you better use the PyCharm IDE, which is
Okay.
freely available.
Mm-hmm.
So where it has a debugging option, okay, there is a bug symbol is available in the IDE.
Okay.
Wherever you are getting a doubt, so you put a breakpoint and then see what's wrong with your code. That is the only way of tracking out the bugs in the code, and we can easily understand what it is reporting in the code, because the IDLE is not giving exactly what is the error. We may not be able to understand also. So better use
Okay.
the PyCharm IDE so that you can easily understand the bugs.
Okay. The syntax should be same, right?
Syntax is same, sir. We don't need to change. Only thing is we need to work with the specific IDE only, not the IDLE editor,
Okay.
which comes
IDE
with the
only.
Python default. Yeah.
Yeah, PyCharm IDE. Okay.
Yes, sir. Yes, sir. PyCharm IDE. That is
Okay.
the best IDE for Python.
Oh. Okay, sir. Thank you so much.
Yeah.
Sir,
Yes, ma'am.
can you suggest any dataset for satellite images?
You need to download from Landsat 8. So the Landsat 8 imaginary, which is freely available, which is given by NASA. I'm
Sir,
not sure the name.
could you please type in the chat box, sir? Your voice is breaking.
Sure. Yeah, sure. One second. Obtain the satellite images from the Landsat 8, ma'am.
Okay.
Landsat 8. So you can download freely from the, but you need to log into the server. I forgot the name of the server actually. The NASA is going to give you the access of the Landsat 8, but you can download only one tile at a time from the Landsat 8.
Okay.
The tile size is predefined. You cannot use the you cannot use how many number of tiles you want to download. Okay. So
Okay.
the advantage is that Landsat 8 has a 11 bands it will give you, and then it is up to you how many bands you want to join and then analyze your satellite image data.
Okay. And
But there is,
processing of
yes, ma'am.
satellite images, is it comfortable with Python, sir, or MATLAB?
You can do it in the Python. The only thing is that it is better to run in a server, not in a desktop or not in a laptop.
Okay.
At least minimum of a rack server is necessary, because to download the one tile of image from a satellite, it is almost consuming the 12 MB of data is going to download from the Landsat 8.
Okay.
It is in huge data, so better to use the server versions. So
Okay.
Python is good enough. You don't need to go for even a MATLAB also.
Okay. Thank you, sir.
Any more clarifications you need, participants?
So this is the drawback of the current CNN models, that they can run very fast in the GPUs only. Not even, it is not advised in the CPU. So GPUs are very fast in the computation process. So all these libraries are supporting the GPU coding also. You just mention the one flag or a piece of code within your Python, so it automatically runs in the GPU module. You need to write a GPU coding here. So the library take care of your job. We don't need to run it.
Sir, namaste, sir. Sir, this is Anant Narayan speaking from Hyderabad, sir. Sir, there is a
Yes,
past
sir.
historical data in visual form, sir, of
Okay.
charts and graphs of previous performance of stocks, and using
Okay.
that data, is it possible to predictable for future trading using convolution neural network, sir, or which is a good one compared to convolution neural network and recurrent neural network, sir, in prediction?
CNNs, two things CNNs can be used here. One is that 2D images, definitely it is very accurate. The other one I have mentioned is for a text data, whatever the text data that you have, that means NLP purpose, the CNNs, 1D CNNs are effective. But when it comes to the stock market, because they are actually the time series models, you better to use the RNNs than the CNN. That is my advice.
Yes, sir.
Because CNN models are not specific to time series models. It is not meant for the time series models.
Yes, sir.
Okay.
Thank you, sir.
So the AlexNet is run for one epoch. It took almost the 15 minutes, and it returns the test accuracy is 83. And the other one is still okay. This is also finished. Just for 5 epochs. Okay, the training and testing accuracy, the validation is just calculated here, and here I am giving the test data as a one of the sample from the part of the sample is giving as a test data how it is going to be actually predicting, and let's see that whether it is going to be predicted from the same class or not. So this is taken from a tomato late blight. Let's see that whether it is predicting the same or different. If it is different, that means the training is not done yet properly. Okay.
Yes, sir.
So while you're testing, you need to convert that image into a numpy arrays, because you need to flatten the one single image, convert that entire image into numpy arrays, or maybe we have a expand the dimension as a axis to 0. That means automatically it is converting to as a vector form. So these are the classes that we have considered, and here I am going to read the image as an array and extend it to a single dimension here. And then we have a model, whatever the model that we have used, which is 16, and these are the weights that is written for that entire predicted the entire image. And then we can plot the image, what is the class that it is going to be classified. So this is the image given as a test, but it says that tomato mosaic virus. But what is the class that we actually drawn from is the late blight. So if you do these repeated trainings, if you increase the number of epochs, because the training accuracy here is that only 80% or something. Okay, so here maximum is 80%. So if you increase the number of training time and then iterations, it will go up to 95% or something. Then this class can be classified accurately. Okay, so this is how we can predict using the predefined or a pre-trained CNN models, and these are the your own custom models can be created using Keras library. Okay.
Yes, sir.
Thank you.
Thank you, sir.
Sir,
Yes, ma'am.
in Landsat 8, you had sent the website, na sir?
No, ma'am, I didn't send it. I couldn't actually recall what is the website URL exactly.
Okay.
You can search the Landsat 8 data.
Actually, I opened, sir. So in that, how we need to download that data set, sir, depending on application?
You have to log in and then select the map and then
no,
type.
sir. Only main screen, sir. So on the main screen, we have gallery as well as application, sir. So which application, for which application we are searching for? So how we need to download, sir? Depending on application or simply by gallery?
Application, because what you want to focus on, agriculture or maybe rivers or deserts, what is your interest, or forest. So based on that, it is going to give you the data.
Okay, actually I supposed to do on road extraction, sir. So which one I need to download?
I couldn't actually recall the classification of the labels. Okay, I have done it very long back. Probably you can just try with the product details that are provided. Okay.
Okay, sir. Thank you.
Generally, it will give you the entire tile, madam. You don't need to classify the specific roads or buildings.
Okay.
The entire tile you can download it as it is. So within the tile, you can analyze whatever you want.
Sir. But in this website, how I can download, like different applications are there, na sir?
1 minute. There is a collection to level 1 census, level 2 census. There are levels are given in the 1 minute. I'll share you in chat the exact URL. So this one of the URL you can directly download. They hosted in Amazon Web Services. The global sense-based data it is.
Okay, sir. Landsat commercial cloud data accessing.
Yes, ma'am.
Okay.
Or so
Any
how
more?
you can download is, I am going to give you one more URL. You can download from this also. They have given how to obtain the Landsat 8 data from the second URL.
Okay, sir. Thank you, sir.
Yeah, okay.
Any more queries from the participants? Okay. Thank you, Dr. Jagan Mohan Reddy sir, for delivering this session on plant disease identification using CNN. Thank you for accepting and delivering the talk on this. Thank you once again.
Yeah, for once again, I'm sorry for the participant for the delay.
Yeah.
So this is the one of the ongoing research in the deep learning. I hope, as I mentioned, that the native plants or native flower classification can be done using these models. I hope those who are continuing in the research, please explore those options, and probably you may get the definitely one paper if you thoroughly do the research and then publish a paper. Okay. Thank you once again inviting me such AACT sponsored short-term program. Thank you, Srinivas sir.
Thank you. Thank you. Thank you for
Okay.
accepting and delivering the same with the
Okay.
practical demonstration. Thank you.
Okay. Sir.
I hope it will helpful to the participants who are working on the particular area.
I request all the participants to fill attendance and feedback form. We have already posted in the Meet and YouTube also. That's all for today's session. Tomorrow we have the sessions on deep learning for video processing, deep learning for sentiment analysis, and capsule networks, a new deep learning network. Thank you all for your active participation for day 3. Thank you.